Hello, good morning, everyone. Let's start our revision session. So, before going on to the revision session, let me show you the syllabus copy. So, I will now quick recap Unit 1, then I will go for Unit 2. Okay. So, I think you are able to see my screen, right? So, I will be dealing the first topic, the transition from classical to quantum physics. Okay. So, going on to the transition from classical physics to quantum physics. So from classical to quantum, so classical physics always deals with large objects such as stars and planets, whereas quantum physics always deals with tiny particles. That you need to remember. So the tiny particles are nothing but electrons, photons, etc. So one example I can give for a classical physics, that is nothing but if I throw a ball, if I throw a ball, I know where that particular ball will land and what is the speed of that particular ball. Okay, so these all comes under classical physics, whereas in quantum physics I can say I am in a room where there are n number of subatomic particles such as electrons, photons, or waves, etc., etc., but I can't exactly say where my wave is and where the electron is, right? So that is what about quantum physics. Okay. So whereas classical world is will be certain because it is deterministic. Be- I can predict the future easily. But whereas in quantum, it deals with probabilities. It is completely dealing with probabilities. I can't exactly know what is the outcome, and I can't exactly predict what is the outcome. So it only deals with the probabilities that you need to remember. So energy in classical is continuous. For example, if I throw a ball, the energy will be continuous. But whereas in quantum world, it is quantized. The energy will come step by step. It is not like continuous. That is, we call it as quantization. Okay. So if you look into this example, the energy is going continuously, coming continuously in classical. Whereas here in quantum, if you see this particular picture, the energy comes in steps. That is what the difference between classical to quantum. I think this point you are getting right. So I given a quick recap, that is nothing but some differences between classical physics and quantum physics. So classical physics always deals with large objects such as I already mentioned, it deals with cars or some planets, that is nothing but large objects. But whereas quantum physics always deals with atomic and subatomic particles like photons, electrons, or atoms, etc., etc., that comes under subatomic particles. The nature of classical physics is deterministic. Deterministic, you already know. The future is fixed, right? Whereas in quantum, you always get the probabilities. If I toss a coin 1024 times, I only get the probability of heads. For example, probability of heads is 512 and probability of tails is 512. That is probability. I can't say exact number. I can't say head is this number and tails is this number. I just say the probability. So the probability of getting heads is this many times and the probability of getting tails is this many times. That is what about quantum physics that you need to remember. Whereas in quantum, the energy comes continuously, not in quantum, classical, sorry. In classical, the energy comes continuously, whereas in quantum, the energy levels are discrete. That is nothing but quantization, right? So in classical physics, observer effect will not affect the system. For example, if a ball is thrown, I am observing. For example, I am fielding in a cricket stadium and someone hit the ball. If I watch the ball, it won't affect and it will land where it wants to land. But whereas in quantum physics, if the same phenomena applied to quantum, if someone is observing, then the state of that subatomic particle will change. That is what you need to remember. That is the huge difference between classical and quantum. So observer effect changes the role in quantum. Okay. The laws in classical physics are nothing but they behave or they uh, obey Newton's laws, whereas here they will follow wave mechanics, such as sound, etc., etc. Are there, right? So that is the small difference. Now, I think this example I will skip. It is not required for you. So why quantum physics matters? Why it matters? So it helps us to understand how atoms and light behaves. For example, in quantum communication, we'll be using photons, right? I think I have explained in quantum key distribution already. So in quantum key distribution as well as in quantum internet, quantum teleportation, all we'll be using light particles that are nothing but photons. So it makes the calculations in very power way, that is nothing but 2 power n times faster than a classical computer. So it forms what does quantum physics do for quantum communication or quantum, that is nothing but it forms the base for quantum computing, quantum communication, and as well as quantum sensors. So quantum theory leads to modern tech like lasers, LEDs, MRIs. So it will change. That is why we require to change from classical physics to quantum physics. I think this is the first topic in the syllabus. I will mark this. So this will be our first topic. We have finished transition from classical to quantum physics. Okay. Now, moving on to the fundamental principles of quantum mechanics. Okay. So, I again say that if any question comes regarding these particular question, you need to write all those three, four types. So, one is superposition, and the second one is entanglement, and the third one is uncertainty principle, and the fourth one is wave particle duality. I think these 4 points is clear to you, but I will explain once more. So you already know what is superposition. Let me give a simple example for superposition. So if I toss a coin, let me give a simple example. If I toss a coin, I will be having two states. That is nothing but heads or tails, right? So if it land on my hand, it will be having only one state. Either it may be heads or tails. That is what about classical systems. But whereas the same coin tossing in the air, let's think, just imagine it is tossing in the air and flipping in the air. Okay. Now you can't say whether the flipping coin is at head state or tail state because it is flipping in the air. It has two states. The two states are nothing but we call it as superposition. Okay. Two states at a time. We call it as superposition. Whereas classical deals with only one state, either 0 or 1, either head or tails. So a quantum particle can be in several states at the same time. Several states is nothing but two states. I have took the example of coin. That is why I have two states at a time. It may be n states at a time. That is why quantum is more powerful than classical system. So this is called superposition. Two states at a time. Simply you can remember it. I think it may be coming for 2 marks, or it may ask if the question frames for 5 marks, the four topics may be there in your exam. If they wanted to ask for 2 marks, they may ask you define superposition. So I think this is clear. You need to write the mathematical form of single qubit. So this ket psi is nothing but represents the qubit. Okay. Alpha is nothing but the probability amplitudes of ket 0 and ket 1. This ket 0 and ket 1 I think you already know, right? So this is ket 0. Please write all these notations in the exam. Ket 0 will be nothing but classical 0. Okay. Ket1 is nothing but classical one. Let us say head or tails. Simply I am writing in quantum way, that is nothing but Ket0 and Ket1. That please write all those formulas. Okay. So mathematical form of single qubit is nothing but ket psi is equal to alpha Ket0 plus beta Ket1. And where here alpha and beta are nothing but the probability amplitudes, and that should be equal to mod alpha square mod plus mod beta square is equal to 1. Please check, try to check for 1 by 2, 1 by root 2, Ket0 plus 1 by root 2. I am not able to write fastly here. 1 by root 2, Ket1. If you check them, the mod alpha square of this Ket1 by root 2 will be 1 by 2. If you check for Ket1 also, if you take mod 1 by 2 plus 1 by 2, 2 by 2, that should be equal to 1. Then only the qubit is valid. That you need to remember. Okay. So you try to write the example also. You try to take one example, that is nothing but 1 by root 2 ket psi is equal to 1 by root 2 Ket0 plus 1 by root 2 Ket1. If I measure the probabilities of Ket0 and Ket1, that should be is equal to 1, and you try to solve this example if any question comes regarding superposition. Okay. Now I have given one example here. I think you already know. I am taking a qubit state of Ket0 and I am applying Hadamard gate. You already know this formula, right? So if we apply Hadamard gate with Ket0, I think 1 by root 2 Hadamard gate mathematical representation 1 by root 2 1 1 1 minus 1, right? So you already know Ket0. What is the Ket0 column vector? 1 0, right? Sorry, 1 0. So if you do the matrix multiplication, you will be ended up getting this. That is nothing but 1 by root 2 Ket0 plus 1 by root 2 Ket1. If you try to find out these probabilities for Ket0, 1 by root 2, for Ket1, 1 by root 2, if you do these uh, uh, calculation, you will be end up getting 1. So that is nothing but 50% chance. That is nothing but if you measure the probability of Ket0, you will be getting 1 by 2 chance for to get Ket1. That is nothing but Ket0. If you measure the probability of Ket1, you will be getting 1 by 2 chance, right, for Ket1 also. So after measurement, it will be collapsed into a single state. That you need to remember. So as I am suggesting that you try to define what is superposition and then write this example. If it comes for 2 marks or if it comes for 5 marks, try to go through this particular example. Okay. Now moving on to another interesting topic, that is nothing but entanglement. Okay. What is entanglement? For example, I'm explaining with some example. You think I'm having two particles, particle 1 and particle 2, and they are entangled. Just think they are entangled. If they are entangled, then what happens is nothing but if I measure particle 1, automatically I can say what is the state of particle 2. If you see this formula, these are 0 0 is nothing but these are the bases of particle 1 and particle 2. 1 1 is nothing but these are the bases of particle 1 and particle 2. If I measure if I measure particle 1 as 0, automatically I can say particle 2 is 0 if they are entangled. So what does it mean? What does it suggest is nothing but if I measure, if I am having two particles, particle 1 and particle 2, if I measure one particle, I can determine the state of another particle. So simply I have given a textbook definition here. Entanglement means two qubits share a single combined state. So changing one qubit instantly affects the other. If I change these as 1, instantly other qubit also change it to 1. If I change this qubit as 0, instantly other qubit will be also 0. So the simplest entanglement state is written like this. So this is nothing but Bell state. This is nothing but Bell state. You can write in exam, you try to write all those terminologies in exam, it will reflect you. Okay, Bell state. I can't write, you please note Bell state. So this is one of the Bell state used in communication and teleportation. So Bell states are four types. This is enough for entanglement concept. I think this is clear. All right. And you please note, this is the circuit you need to write. So how this entanglement is created, please look. This equation is came from this particular circuit. Initially, please draw this circuit and try to practice with me. So initially, every qubit starts with ket 0. Okay. So this is 2 qubit system, 2 qubit circuit, and then followed by this H is nothing but Hadamard gate, and then followed by this is nothing but this we call it as C0. What is that? C0. So this symbol is, this represents control, and this plus represents target. Please write. I'm not able to write here properly. This represents target. So this plus symbol represents target, and this dot symbol represents control. This dot symbol is at Q0, and this plus symbol is at Q1. You please remember. Please draw this circuit. I will go and work with mathematically. Okay. So if you start initially, if you look here, initially the qubit is at ket 0, 0. That is nothing but I have combined 2 qubits, qubit 1 and qubit 2. So that is nothing but if I combinedly write them, I can get these particular equation, ket 0, 0. Okay. Now I'm applying Hadamard gate. Hadamard gate is only for first qubit, right? You need to remember this. Hadamard gate is only for first qubit. It is not for second qubit. So if I do Hadamard gate with first qubit, you already know this will happen. 1 by root 2, ket 0 plus ket 1. So then after that, so after that, if I do the tensor product, then you will be getting this. Okay. I think this is clear, right? Please do solve with me. That is why I'm stopping here. So if you do the tensor product, then you will be getting this, right? If please do. I think tensor product is clear, right? So tensor product of, let me explain tensor product ket 0, 0, tensor product with ket 0, 0, ket 0, 0, ket 0, tensor product with ket 0, then I will be end up getting ket 0, 0. That you need to remember. So if you do the tensor product with ket 0 here, so ket 0 tensor product with ket 0, ket 0, 0, ket 0 tensor product with ket 1, then you will be getting ket 1, 0, right? So after applying Hadamard gate, this is our state. This is our 2 qubit system state after applying the Hadamard gate. Now you move on to another level, that is nothing but if you move forward, then there you see one gate, that is nothing but C0 gate. So control is for first qubit, the dot symbol represents control. So control is for first qubit and target is for second qubit. So if you do, if please look, control flips the second qubit only when the first qubit is 1. So that is nothing but if control is 0. For example, this is my 2 qubit system. I am getting ket 0, 0 and ket 1, 0. Before this step, you please look ket 0, 0 and ket 1, 0, right? So control is at first qubit. So if you look, the control is at first qubit and the target is at second qubit. Okay. If control is 0, it won't change. It will come as it is. So it remains as it is. That is nothing but 0, 0. It remains ket 0, 0. So if the control is 1, if you look here, the first qubit is 1. If the control is 1, control won't change. Control will be same And what happens is nothing but target flips. Target flips is nothing but if it is 0, it flips to 1. If it is 1, it flips to 0. So that is what I have written. After applying C naught, 1 by root 2 ket 0 0 plus ket 1 1. Right? And this is what the equation, right? We get, and this is what the Bell state equation, right? I think this is clear, right? And now moving on to one more important fundamental of so I'm again and again saying, if they give only for 2 marks what is entanglement, then try to write until here. This is enough. If it is for 2 marks, this is much enough. If it is for 5 marks, so try to draw this circuit. This circuit is must, and then you try to write all those steps, and then you close it. Okay. Now moving on to another thing is nothing but uncertainty principle. So uncertainty principle is nothing but it is proposed by Werner Heisenberg. It is also called as Heisenberg uncertainty principle. So it states the position and momentum, okay, cannot be known exactly. For example, if the fan is rotating, let's just think of one example. If a fan is rotating, you can't know exactly the position and momentum of that particular fan, right? That is what Heisenberg uncertainty principle say. So the relation is nothing but written as ket x, I'm sorry, delta x into delta p less than or equal to, okay, greater than or equal to, sorry, h by 4 pi. So these delta x is nothing but change in position. Delta P is nothing but change in momentum. Already you know H. What is H? Planck's constant. What is that? Planck's constant. So these you need to write. If they ask uncertainty principle for 2 marks, this is enough. Okay. You need to write this formula exactly what I mentioned here. That is enough. Okay. Delta X into delta P less greater than or equal to H by 4 pi. Okay. So you need to write this is proposed by Wegener Heisenberg, and this is also called as Heisenberg uncertainty principle. And then we cannot know exactly the position and momentum, okay, at same time, and the relation is delta x into delta p less than or equal to h by 4 pi, and where delta x is equal to change in position and delta p is equal to change in momentum, where h is known as Planck's constant, that is nothing but 6.663 into 10 to the power minus 9 joule per second. That you need to write. I think this is clear, right? Now moving on to another simple uh, fundamental, that is nothing but wave particle duality. So wave particle duality, name itself has wave particle duality. Dual, what is dual? That is nothing but double role. So if a particle or a wave acting as both wave and particle, that we call it as wave particle duality. So one example I can give, it is nothing but light. Light can travel both waves as well as particles. So so these wave particle demonstrated using double slit experiment. You already know double slit experiment, right? So I'm having two slits. One is this, and second one is this. I am sending the light energy through these two slits. Okay, and if it go inside, it will form interference interference pattern. So this is, we call it as interference pattern. Interference is nothing but two or more waves collide each other and travel. That is, we call it as interference pattern. So, and this hits a black screen. So this hits a black screen. After hitting the black screen, it will be as particle. It will be as particle. But until then, it travels through this closed environment, it is behaving as waves. That is why we call it as wave particle duality. So without observation, if I am not observing, if I am not observing this pattern, this will travel as interference pattern. If I observe this pattern, then they will go like this. This pattern will be collapsed. No more. That is what observer effect do in quantum. That is what observer effect affect the quantum system. Okay. So the wavelength of the particle is given by lambda is equal to h by p. Okay. So lambda is nothing but wavelength, p is nothing but position, and h is nothing but Planck's constant again. I think this is clear, right? If it comes for 2 marks, you try to write this. If it comes for 5 marks, please try to demonstrate double slit experiment also. Okay. I think this is clear, right? Yes or no? Please try to have some conversation in comment box such that I will also know whether you are listening or not. Is that clear, or should I explain some other way? Please let me know in the comment section and I will proceed next. Everyone please be active. So it is not like one side war, it is for you people. I am doing all those things. Thank you, thank you. So I'll proceed for the next topic. So I think fundamentals of principles explained. That is nothing but superposition, uncertainty principle. Everything is done, right? So now moving on to one more topic, that is nothing but classical versus quantum mechanics. So I will remove these two. So classical versus quantum mechanics. So if a question comes, I'm again and again saying it will be for 5 marks. At least they will ask for 5 marks. For if they are asking for 2 marks or 2 mark question, it will be like only for just 2 points you need to write, demonstrate. So I'm asking, I'm saying this for 5 marks question. So try to figure out. So I can say that classical computer process information using bits. That you need to write the first definition. So they are processed using bits. That bits are nothing but binary digits 0 and 1. Whereas quantum computers use qubits. They can be 0, 1 or both at once. Both at once we call it as superposition. So these special ability gives quantum computers their amazing power. So that is the reason it makes quantum computer to work exponentially 2 power n. Okay. So classical bit is like uh, on and off, whereas quantum bit is like spinning coin, both heads and tails in the air. I think this is clear, right? So classical is nothing but bit 0 and 1, whereas qubit alpha ket 0 plus beta ket 1. Where, and I'm again and again saying this equation should be there in every question, because if any question comes regarding classical information versus quantum information or superposition, you need to write all those equations. Okay. Where mod alpha square plus beta square is equal to 1. This we call it as normalized condition, right? So I have given some differences. So classical information is done using bit, that is nothing but 0 and 1, whereas qubit, quantum information is processed using qubit, that is nothing but superposition of 0 and 1. It is definite state, that is nothing but deterministic, whereas here probabilistic, and it is represented by voltage or charge, but whereas it is represented by photons, electrons and atoms. Okay, it is processed one at a time, one calculation at a time. So but whereas quantum information process many possibilities at a time because of superposition. That you need to remember. Copying is possible, whereas copying is impossible. That is nothing but no cloning theorem. What does no cloning theorem says? No cloning theorem says that we cannot copy exactly the arbitrary quantum bit. Okay, that is why from there this particular point is given. Swapping is impossible in quantum. So it is nothing but it has deterministic output. That is nothing but the future is fixed. If I'm tossing a coin, the future is fixed, whether it is heads or tails. But whereas in quantum, probabilistic output. Okay. In classical information, we'll be using some logic gates. Already you know, AND gate, OR gate, NOT gate, NOR gate, XOR gate, etc., etc. Right? So whereas in quantum gates, poly X gate, poly Y gate, poly Z gate, Hadamard gate, CNOT gate, Toffoli gate. I think this is clear, right? So data is stored in zeros and ones, whereas data is stored in wave amplitudes. Okay, these 8 points you need to write, and still I am continuing some points. At least you try to write at least 10 points. Better if you write 15 points, it will be better. Okay. So whereas in classical information, communication uses electrical signals, whereas here it uses entangled photons for communication. Okay, a classical information can be hacked and intercepted, but whereas here it is secured due to quantum key distribution. You need to write these terminologies. These terminologies makes your paper strong. You will gain marks by using these terminologies in exam. I'm again and again saying. So there will be no entanglement in classical information, but whereas in quantum information, entanglement links qubits over distance. Right? Error correction is simple because one calculation at a time we can identify the error, we can easily simplify the error. But whereas in quantum error correction, it is some complex compared to classical. So no interference. There will be no interference pattern. No interference. If the terminology comes, you need to remember this pattern. But whereas in quantum, interference enhances computation and we can easily scale the qubits, but whereas here it is hard to maintain because of decoherence is nothing but noise. Okay, noise from the environment. If noise comes from the environment, the qubit will be collapsed. It is used in normal computers, whereas it is used in quantum computers. Some companies I already said in the class itself, IBM and Google Sycamore, IBM will be using these fundamentals, right? So classical bit is nothing but 0 and 1, right? Whereas quantum bit ket 0 and ket 1. Ket 0 column vector representation is 1 0, and whereas ket 1 column vector representation is 0 1, right? So and I'm again and again saying this equation comes everywhere. Ket psi is equal to alpha ket 0 plus beta ket 1. The coefficients alpha and beta represent the probability amplitudes. If I want to calculate the probability of ket 0, mod alpha square. If I want to calculate the probability of ket 1, mod beta square, right? So reading a bit doesn't change its value, but if you check, you can check the same result. But measuring a qubit collapses either it 0 to 0 or 1. If you measure it as 0, it will collapse to 0. If you measure it as 1, it will collapse to 1. It will lose the original superposition. Okay, data can be perfectly copied. I think all these I have mentioned. So security point of view, the quantum key distribution I will explain in the fourth unit. I will as of now I will skip this. So why quantum is more powerful is nothing but it has parallelism because of superposition. It can test many possibilities at a time. Okay, so I think this is not required. I think this is about classical information versus quantum information. This, if you write this at least these 15 differences, then it is enough. If you write at least these 15 differences, if a question comes, either it may be 10 marks, either it may be 5 marks, please at least try to write 10 to 15. I won't say you to, I won't encourage you to write only 5 differences. Okay. I think this is clear. I'm marking here. Classical versus quantum mechanics. If any question comes, classical versus information versus quantum information, classical mechanics versus quantum information, the answer is same. Okay. Now, quantum states and measurements. I think here it is there. Quantum states and measurements. Moving on to another topic. So what are quantum states? In quantum mechanics, every system such as electron, photon, or qubit is described usually. I'm again and again saying ket psi. This is how we represent quantum state. Ket psi is equal to alpha ket 0 plus beta ket 1. So I think this is done. I won't go much deeper. Now I'm moving on to some definition, some basic understanding how you are calculating the probability. So consider I'm having a quantum state ket 1 by root 2, not 1 by root 2, sorry, of ket 0 and ket 1. If I multiply, I will be getting 1 by root 2 ket 0 plus 1 by root 2 ket 1. So if I multiply 1 by root 2 ket 0 and 1 by root 2 ket 1 will be there. So that is nothing but 1 by root 2 is nothing but alpha and 1 by root 2 is nothing but beta in both cases. You try to remember that formula. So in alpha place, we are having 1 by root 2. In beta place also, we are having 1 by root 2. So if you compute the probabilities, how I want to check the probabilities? If I compute the probabilities, if you look here, if I want to know the probability of 0. So for example, if I want to know the probability of how many times head is tossing, this is how you'll be calculating the probability. Mod outside there will be square, not inside. You need to remember that. Outside the mod there will be square. Mod alpha square. Alpha is nothing but 1 by root 2. 1 by 2. So if you do it for beta also, you'll be getting 1 by 2, right? So if you combine those states and you will be getting 1. If I combine probability of 0 and probability of 1, it will be getting 1. Now I think this is not required. So consider this example. Please try to solve in your book. Please try to solve this example. In alpha place, we are having 3 by 5. In beta place, we are having 4 by 5. Now you know the alpha and beta, right? Please do calculations. It will make you practice before exam. And if you try, you need to write all those things in exam because it will boost your paper. I'm again and again saying, okay. So alpha is nothing but 3 by 5 and beta is nothing but 4 by 5. So if I do mod alpha square plus mod beta square, 3 by 5 whole square, this is mod, sorry, this is mod, this is mod. If I do it, I will be getting 9 by 25 plus 16 by 25, that is nothing but 1. If it is 1, we call it as normalization. Then we can say qubit is valid. If that is not happening, if in the place of 1 you are getting 2 or in the place of 1 you are getting some value other than 1, then the qubit is not valid. That you need to remember. Now if you see here, so now moving on to the important topic, that is nothing but measurement. What is measurement? So if I am computing, if I toss a coin, I need to know whether that is head or tails, right? So that we call it as measurement. But what happens? Why I am specifically targeting measurement in every sentence? So that is nothing but whereas in quantum, it is not like having only one output. It is like spinning coin in the air. If I stop that spinning, it will only collapse to one state. Either it may be head or tail, but it is not in superposition, right? So that is what measurement do. Measurement collapses the superposition state. If you measure it as head, then it will collapse to head. If you measure it as tails, it will collapse to tails. That is what measurement do. So measurement plays a crucial role or special role. It changes the system itself. If we observe When we observe a qubit, we are not merely checking its value but forcing it to choose one definite result. That is nothing but it is spinning in the air and you are forcing it to stop and you are forcing it to go to one output. Either it may be head or tails, right? So the collapse, it will collapse to either one or either 0 or 1. Okay. So before measurement, let's think it is at two states. After measurement, it only becomes to get 1. Okay. So if you look at this example, you will be getting much probability for ket 1. That is why after measurement it becomes to ket 1. And this phenomena is known as collapse of wave function. and until you measure it, it is at two states at a time and it satisfies normalization. But you measure it, you will be getting high probability for 4 by 5, and you're getting only one output, that is nothing but ket 1. Okay, I think this is clear. I think this is not required. I think this part is clear. I think we finished quantum states. I think nature of observation is also required. Let me clear it out. Clear it out. So the nature of observation. So observation in quantum mechanics is not passive. It actively changes. That is what I explained, right? If it is spinning in the air, if I try to catch it forcefully, then it will only have one output at that particular stage. Either it may be head or tails. That is what observer affect the quantum system. If the quantum system is in superposition state, if someone wants to observe it, then it will collapse to only 1 or 0. So if you look here, before observing, it is at ket psi is equal to alpha ket 0 plus beta ket 1. But after measuring the quantum system, it behaves like particle, that is nothing but 0 or 1. Okay, that is what about observer nature of observation. And you need to write about double slit experiment, that already covered. I think this is clear, right? And we have finished quantum states and measurements, nature of observation. Now moving on to another important topic, that is nothing but some overview of quantum systems, electrons, photons and atoms. And I will explain through some class notes, or better, if I am having any PDF. No, I am not having. So I will go through the class notes. Where is this? So better. So electrons and photons are nothing but so I think this part is missing. So if electrons are nothing but, wait a minute, let me check. So electrons are nothing but fundamentally charged particles with spin. So we are having two spins. That is nothing but, I will explain. I think somewhere it is there, but not able to see. But no issues. So electrons are nothing but it will be having two spins, either half plus half or minus half. Okay, electrons are nothing but tiny particles. You already know. They obey Pauli exclusion principle. Okay, no two electrons can occupy the same quantum state in an atom. For example, if I am having a box, okay, of two electrons, if it is upward, what does Pauli exclusion principle say? It should the second should not be upward. The second should be downward. If it is upward, then it will be collapsed. Okay, that is what Pauli exclusion principle says. So electron orbitals in atoms are nothing but S, P, D. Already you know, right? So electron interference in double slit experiment. You need to write about, if a question comes regarding electrons, overview of systems, quantum systems, you need to mention double slit experiment also. Double slit DSP. DSC I will write, double slit experiment. Okay. And now moving on to another thing is nothing but photons. Photons are nothing but tiny particles of light. Okay. So it will travel at the speed of light and carry the energy and momentum. And you already know in photon qubit, what are the types of photon qubit? Polarization qubit, time qubit, path qubit, everything you know, right? So that you need to write. So the key roles are nothing but photoelectric effect, quantum communication. So these photons are used in quantum communication, quantum internet, and everything. Everywhere now they are using only photons. So they will be using linear optics for quantum computing, and this you need to write about photons. And atoms you already know. Atoms are nothing but it consists nucleus. So nucleus is nothing but protons and neutrons. So so emission and absorption of light occurs when electron jumps levels. For example, so this is how. So if it jump here, it will gain some energy. If it jump here, it will gain more energy. If it jump here, so that is how atoms gain energy. This we call it as quantization. Okay, that you need to remember. This is enough about electrons, photons, and atoms. If I need to share this matter, I will share. No issues. And now moving on to another concept, the concept of quantization. So quantization is nothing but I already explained here. The energy is not continuous. The energy comes in discrete steps. Okay. The energy comes in levels. At step by step, it gains energy. It is not like continuous. Okay. So that is what about the concept of quantization. And now I will move to another topic, that is nothing but why quantum scientifically, sorry, why we require quantum scientifically, technologically, and everything I will explain through your class notes. So why we require quantum? If you see here where she has written, so please look, why quantum? So scientifically it helps us to understand. If you look here, I think scientifically, it helps us to understand the building blocks of the universe. Scientifically, I'm saying why we require quantum. Already, you know that why we require quantum. In the first 10 minutes, I've explained why we require quantum and why scientifically how it is. How it is. So, scientifically, it helps us to understand the building blocks of the universe. In technological terms, it enables ultra fast computing and secure communication. Okay. In say technologically, it helps us to do ultra fast computing and a secure communication. I think in Unit 5, again, I mentioned this very elaboratively. You try to write that. I have mentioned some bullet points here, but Unit 5, I have mentioned it very clearly. Okay. Now, in strategically, many countries wants to have quantum advantage for defense like AI and cyber security. Okay. So quantum computers can solve complex problems faster than supercomputers. So quantum communication is 100%. I think this is about these particular things. So now moving, I will explain quantum communication, quantum sensing later. And you already know national and global quantum missions. India has initiated national quantum mission with the budget of 8,000 crores. And I will explain Unit 5 here itself. Unit 5, where is Unit 5? I think here I explained, right? Somewhere here. So if you see here, where is that? If you see here, you need to write this question for that particular answer. If any question comes regarding national quantum mission, so India is building its own quantum ecosystem through national quantum mission. So it is in between 2023 to 2030. So this mission has already funded 8,000 crores. Okay, focus on and it focuses on three main pillars. What are those three main pillars? Quantum computing, okay, quantum communication, and quantum sensing. So what is quantum computing? Where this quantum computing has been initiating? So I already IISc Bangalore and IIT Madras building Indian quantum qubit processor. Okay. TIFR Mumbai. TIFR is nothing but Tata Institute of Fundamental Research. It is working on quantum error correction. What is quantum communication? So I will explain this in Unit 3. So quantum communication is been introduced by ISRO and DRDO and tested India's first 50 km QAD. That is nothing but they are entangled two particles and they have made a distance between the two particles is nothing but 50 kilometers, and they have transferred the energy or they have transferred the information in this 50-kilometer range, and the aim is to launch a quantum secured satellite by 2027. That is the aim of India. Okay, by 2027 they need to launch the satellite. And what where this quantum sensing will be used? Quantum sensing has been working by NPC Delhi, that is nothing but National Physical NPL Delhi, sorry, National Physical Laboratory. So it is building ultra accurate atomic clocks and magnetometers. Okay. This unit, right? If any question comes regarding national and quantum global mission, and you need to mention European states and European countries, and as well as USA and China. And I think I mentioned here already. Where is that? So European Union is developing a project called Quantum Flagship, mainly focus on quantum computing and quantum internet. Okay. And whereas USA is working on a project called Quantum Initiative, which focus on national network. It is like they want to spread this quantum worldwide. It is not like only we want to use or only we want to utilize. They want to sell it for, they want to do business for, well, that is nothing but globally. And China is working on a project called Mesius satellite. Already they have done one experiment around 700 kilometers, this Mesius satellite, and they have performed. And they from there they said that quantum key distribution is very secure. Okay. And at last, I think these 3 points, if any question comes from unit 1, these 3 points you need to write. National quantum mission, if any question comes regarding this, you need to write these three. And even Japan also developing a project called Innovation Hub, which focus on semiconductor qubits. I think this is enough. I think this is enough for this at this point. I think we finished unit 3. I will explain quantum computing, quantum communication, quantum sensing in unit 5. I think this is clear. Is this clear? Let me know in the comment section. If it is clear, I will proceed. Now shall we move to unit 2? If yes, let me go. I think unit 1 is very easy. I am again and again saying you try to score marks in unit 1. Okay. So unit 1 is very, very easy. Easy. If any question comes from unit 1, like they may ask some questions regarding the fundamentals of quantum. You need to write superposition, entanglement, uncertainty principle, wave particle duality. If they ask any 2 marks question like what is superposition, what is entanglement, what is uncertainty principle, I said right, that you need to write. I think this is clear, right? If I need to proceed, shall we proceed to unit 2? If yes, let me know in the comment section. Shall we proceed? Yes, no. Thank you for the confirmation. So in the second unit, we are having the first topic, what is qubit? Okay, I will explain here. I think this I need to remove it. So in the second unit, we are having the first topic is nothing but what is qubit. You already know. Whereas in classical computers we'll be using bits, whereas in quantum computer we are using quantum bits. A qubit is nothing but is also known as quantum bit, which is the smallest unit of quantum information. Okay. So a classical bit can be either 0 and 1, but whereas a qubit exists in superposition of states. Again, the same equation. Please, I am again and again saying you need to write this equation everywhere. If you see any question regarding superposition or qubit or anything, ket psi is equal to alpha ket 0 plus beta ket 1, where alpha square plus beta square should be equal to 1. This is about qubit. Now, what is there? So, and these all are nothing but types of qubits. Better I will go through this. Okay. So, there are different types of qubits are there. Okay. So one is spin qubit, another one is trapped atoms and ions, and third one is photon qubit. In photon qubit, we are having polarization qubit, time bin qubit, and path qubit. And the fourth one is nothing but superconducting circuit qubits, quantum dots, NV centers, that is nothing but nitrogen vacancy centers in diamond. I'm again saying these types of qubits will be there in unit 3. In unit 3 it will be there. Unit 3 it will be there. Unit 4 it will be there. So try to listen carefully. If you are not understanding, let me know in the comment section. I will explain very clearly. So in every unit it will be there what is required to build a quantum computer. You need to write all those things. What are the types of qubits? Okay. Let me go through the first one, spin qubit. So in an electron, we'll be having two spins, up and down. Okay. So if it is upward, the state is represented as ket 0. If it is downward, the state is represented as ket 1. So the spin qubit use angular momentum. So how to know this, whether the spin is upward or downward? So by using angular momentum of electron, we are no, we are saying that the spin is up in upward direction and the spin is in downward direction. So a superposition of both direction form a quantum state. Okay. This is and advantages is nothing but okay, magnetic or microwave fields flip and manipulate the spin orientation. If it is spinning upward, and we will be using micro fields or magnetic fields to manipulate, and we are making that spin direction to change to downwards. I think this is, you need to remember, in every qubit we'll be having control. The control are nothing but magnetic or microwave fields or lasers or microwaves. Simply I can say, because I am using these terminologies in class every time, lasers and microwaves. Okay. So advantages of spin qubit: simple physical concept and small size, compatible uh, with semiconductor materials. That is what about the advantages of spin qubit. But what are the disadvantages of spin qubit? Sensitive to magnetic noise. If some magnetic noise occurs, then the spin changes automatically and the information may be lost. And requires cryogenic cleaning. You already know, minus 273 Celsius it requires. Minus 273 degrees Celsius. Even for superconducting circuits also it requires minus 273 Celsius. Okay. So I think this is the diagram. If it is spinning up, ket 0. If it is spinning down, ket 1. I think this is clear, right? Now, moving on to another thing is nothing but trapped atoms and ions. Name itself has trap. Okay, what does this trapped atoms and ions do? Initially atoms and ions will be at 0 state. Only one state at a time. So if it is one state, we call it as classical, right? To make it to move to two states, that is nothing but 1 1 or 1 1. Okay, 0 plus 1. We are making trap. Okay, So what we are doing is nothing but we are trapping it by using lasers or microwaves. Initially, the qubit will be zero state and we are sending lasers onto it. Lasers, or simply I can say energy. Okay. We are sending some energy boost to zero and we are making it to move to zero one simultaneously. Initially, the ground state will be get zero and excited state after applying my energy, that is nothing but lasers or microwaves, it is moving to zero one. Okay, are you clear with this? This is moving to zero one. Initially, it will be 0. Initially, it is at classical state. But when I am sending lasers or microwaves to 0, that is nothing but I am giving food or energy boost to this particular 0. It moves to 0 and 1 at a time. Okay, that is nothing but trap. We are trapping by sending lasers. We are trapping by sending energy to 0 and we are making it to move to 0 1. And to why we are making, we want it to behave as a qubit. Okay, we want that atom to behave as a qubit. That is why we are trapping this. So advantage is nothing but long coherence time. Before saying this, what is coherence? Coherence is nothing but there will be no disturbance from the environment, right? There is no disturbance from the environment, and it is like a closed room. The electron or atom is placed in a closed room, that we call it as coherence. Okay. And here the advantage of trapped atoms and ions will be getting accurate results, extremely accurate results. Okay. And it is ideal for research and precision quantum logic. But disadvantages is nothing but slow operations. Okay. And large experimental setups required because we need to send lasers and microwaves very accurately, and limited scalability as of now. I'm talking up to the date. So initially it will be, if you look into the diagram, initially it will be 0 and I am sending lasers or microwaves, and we are making it to move to excited state. Excited state is nothing but high energy state. I think this part is clear, right? This diagram is clear. Okay. Now moving on to time bin qubit or time qubit. I explained time qubit in the uh, examples in the class. Okay, you need to write that only. So I am having a photon and I am having a beam splitter. BS is nothing but beam splitter. So I am making photon to travel through this beam splitter. If the photon comes through beam splitter early, for example, if many photons are coming simultaneously. So if one particle comes early, I am marking it as ket 0. If another particle is coming late, I am marking it as ket 1. This is about time in qubit. Okay. So formed using beam filters, that is nothing but this BS represents beam filters, and delay lines, they create we are marking if the photon comes early through the beam filters, we are marking it as early arrival, that we are marking the state as ket 0, and late arrival we are marking it as ket 1. So advantages are nothing but excellent stability over long distances and perfect for fiber based quantum key distribution. So it requires fast detectors because it happens in milliseconds. So you need to elaborate that, or you need to differentiate whether the photon is coming early or late. That is why we require uh, fast detectors and need precise time and synchronization. And moving on to another qubit, this all time qubit, path qubit, polarization qubit, everything comes under photon qubits, right? So this, what is path qubit? So here also same thing. I'm again placing the beam splitter. Okay, beam splitter and interferometers. Okay, it is touching again. The photon is touching again the beam splitter. So, but here I am not placing a transparent beam splitter. I am placing something difficult beam splitter to travel. So, if the photon hit the beam splitter or interferometer, and if it goes top way, and if it comes the down path, for example, if it diverges from the beam splitter, if the path, that is nothing but path 1 is nothing but if it is deflecting to top, where I'm marking it as ket 0. If it is reflecting downwards, I'm marking it as ket 1. Okay. And the main advantages are nothing but it integrates easily into photonic chips, Okay, and high control precision will be there for this path qubits. These diagrams please try to write in the exam. Okay. And it requires stable alignment, because if the beam splitter, it may lose some control. If it happens, the information may be lost, and it suffers from phase drift. Okay, so this is what I given the diagram. I'm placing the beam splitter here, and some are going top path and some are coming bottom path. If it is going top path, I'm saying it as ket 0, I'm measuring it as ket 0. If it is coming bottom path, I'm measuring the photon qubit as ket 1. Now moving on to another important thing, superconducting circuit. So superconducting circuit is nothing but, I think I will explain with diagram first. We'll be having a tiny circuit. Okay, so this is nothing but, this junction is nothing but, we call it as Josephson junction. What is that? Josephson junction. Josephson junction. So what does this Josephson junction do is nothing but, it makes the current to flow in both directions, clockwise and anti-clockwise. Okay. This, the main advantage of the Josephson junction is nothing but, it makes the current to flow in this lower resistance, the current to flow in two directions, clockwise and anti-clockwise. If the rotation is clockwise, I'm measuring the qubit as ket 0. If the rotation is in anti-clockwise, I'm measuring it as ket 1. This is about the diagram of superconducting circuit. Now, let me go through the concept. So, tiny superconducting loops carry electrical currents without resistance. This particular terminology you need to stress or you need to highlight in the exam. Okay, this you need to write. If it is clockwise, I already mentioned ket 0. If it is anti-clockwise, ket 1. Okay, this current exists in superposition, enabling quantum behavior. So we'll be using microwave pulses to control transitions between quantum current states. Okay, and it is used for fast gate operation, scalable chip fabrication, which is used by IBM and Google. It requires nearly absolute zero, that is nothing but 50 millikelvin, minus 273, minus 270. Just think of how much infrastructure is required to build such type of superconducting circuits. Okay, and limited coherence time. We are not having, we can't make that qubit to stay without disturbance as in this particular era. So that is why if the disturbance occurs, it may be collapse. Okay. Now, moving on to another important thing, quantum dots. So, a quantum dot is a nanoscalable semiconductor structure that confines a single electron, acting as artificial atom. Okay. If, for example, again here comes the same thing. In an atom, there will be electron spin. Okay. Already you know the spin qubit, right? Spin qubit has two directions, upward and downward. Okay, if it is spin upward, we say electron is present. If it is spinning downward, if we say electron is absent. That is what about quantum dot. In quantum dot, we are having electrons. Okay, so advantage is nothing but, it can be integrated with silicon CMOS technology and relatively fast operation speeds. And disadvantage is nothing but, it is very sensitive. Okay, decoherence. It requires cryogenic temperatures. That is what the disadvantage of quantum dots. So if you look here, we are having a shell. This is shell, and another shell is nothing but protective shell. And inside here, we are having electrons. So in this electron, we are identifying the spin. If it is spinning upward, then we say electron is present in this quantum dot. If it is spinning downward, we say electron is absent in this particular quantum dot. I think this is clear. Now moving on to the last one, that is nothing but nitrogen vacancy centers in diamond. You already know. I think I have given the diagram. Okay. So diamonds are made using carbon atoms, right? So in that carbon atom, what we are making is nothing but, we are replacing a nitrogen atom in place of carbon atom in diamonds. And if you replace that carbon atom, what happens is nothing but it will generate a vacancy space to beside the nitrogen molecule. So this in this particular vacancy we can do the quantum operations. How? So please look here, I will go through the definition. And nitrogen vacancy center forms an one carbon atom in diamond replaced by nitrogen atom, leaving a vacancy. This defect traps. So again, here what we are doing is nothing but in this vacancy we are trapping electrons. If it is electron, you already know, spin up, spin down. Okay, and we are making some quantum calculation by making this vacancy. Okay, this is about nitrogen vacancy. If the electron spin state, it is nothing but upward, we call it as ket 0. If it is downward, we call it as 1, and it is nothing but ket 1. Okay, operates even at room temperature because it is not require a cryogenic cooling, sorry. Long coherence times, excellent for quantum sensing and magnetometers, and difficult to produce identical NV centers. So challenging to scale large multi-qubit systems. This is about types of qubits. I think this part we finished. Until this part we finished. Okay, sorry. Sorry. Oh, yeah. So until this particular points we finished. So that even the same things you can write here also. What is required to build a quantum computer, and where does it comes again? Quantum hardware platforms. Again, the same answer you need to write. Okay, and again where it comes, I will explain better. I will go one by one. So what is required to build a quantum computer? Again, the same answer you need to write. Quantum hardware platforms, again, the same answer you need to write. You need to mention all those things. Now, moving on to another simple topic, quantum coherence and decoherence. I already mentioned coherence is nothing but maintaining a molecule without any disturbance from the environment. Let's say if I am suffering from corona, I'm we are making me to isolate, right? It is like if I come out, there comes the disturbance. Okay, it may spread to other people, but what I am doing is nothing but I am making me to isolate such that it won't it won't affect other people. That is what about quantum coherence. But what is decoherence? If I interact with people, if I so the same corona person, if he interacts or me interacts with the person, then what happens? There comes the disturbance, there comes the collapse. If some other interacting with me, he may be affected, right? That is what decoherence. Simply I can say quantum coherence is nothing but there is no disturbance from the environment. Okay, and it is placed in isolated way. That is what coherence means. Whereas decoherence is nothing but it interacts with the environment. Okay, if it interacts, what happens? The wave function may be collapse, maybe not, it will collapse. Okay, and now moving on to another topic, Hilbert space, quantum states, operators. Okay, and again, let me before going on to that. So quantum information versus classical information. I already mentioned the 15 differences, right? If any question comes regarding quantum information, also you need to write that 15 differences. Okay, and now I will explain Hilbert space, quantum states, etc., etc. Let me go to unit 2. Okay. So if you look here, we are having some types. Okay, before writing Hilbert space, if a question comes regarding Hilbert space, you need to write this. We need to write about abstract state. Abstract state is nothing but in abstract state, a qubit is described using Dirac notation. Dirac notation is now also called as bracket notation. Not see here, bracket notation. Okay, a qubit can be either basic state or superposition state. Mathematically, it is written as Ket psi, this we call it as abstract state. Okay, this equation we call it as abstract state. Okay, now column vector, you need to write what is column vector. A column vector is a representation of state of qubit expressed in 2D vector. So what is ket 0? Ket 0 in mathematical representation, we are writing it as 1 0. Please remember these things. Ket 0 is nothing but 1 0. Ket 1 is nothing but 0 1. Okay. And moving on to the concept, Hilbert space. If any question comes regarding Hilbert space, I'm again and again saying you need to write about abstract state. Abstract state is nothing but ket psi is equal to alpha ket 0 plus beta ket 1. You need to write alpha, what is beta, what is mod alpha square, what is mod beta square, to make some visualization elaboratively. And then you need to write about column vectors. Column vectors, if qubits represented in 2D space, the 2D space is nothing but ket 0 is equal to 1 0, ket 1 is equal to 0 1. I think this is clear. Now moving on to the concept of Hilbert space. In quantum mechanics, a qubit states space also known as Hilbert space. So in Hilbert space, we are having all the possible states of quantum. So that is nothing but all the possible states, mixed plus pure. Okay, you need to write this equation. So this is about the block sphere. The block sphere is nothing but a 3D geometric representation of a qubit. So in this block sphere, the qubit may be here or maybe here, maybe here. If somewhere it will be there, right? So I am taking here. If it is here, let us think. And alpha becomes cos theta by 2, whereas beta becomes e power I psi sin theta by 2. So simply you know the quantum equation formula. Ket psi is equal to alpha ket 0 plus beta ket 1, right? Where you need to replace alpha and beta. Cos theta by 2 and e power sin theta by 2. That's it. That's about Hilbert space. This is enough for you to write about Hilbert space. I think you need to write this diagram also. Okay. I think I already discussed about qubit types, etc., etc. Okay. Now, I think we finished till Hilbert space. And the role of entanglement I will explain in unit 4, no issues. Now I will explain philosophical implications, randomness, determinism, observer role. I think already covered, but again I will cover, no issues. So better coherence and decoherence, refer from this notebook. Okay. You need to write all those things. So here comes, so it is not clear, but I will explain. So randomness. In quantum mechanics, quantum mechanics is not a branch of physics. It shocked the foundation of how quantum reality itself. So before quantum theory, the classical view was that so the classical we can predict easily. If I throw a ball, I said the example from early itself. If I throw a ball, it is predictable where the ball will land. This is how classical things are predicted. But whereas quantum theory brought uncertainty, probability, and idea of observer can change the reality. If I observe a ball, someone hit a ball, I observe that someone is catching it. But if I observe it, the ball is not changing the direction or the ball is not moving another way, right? But whereas in quantum, if I observe that same particles, they will change instantly. That is what they brought, the quantum brought to quantum mechanics. Okay. Now randomness. What is randomness? It means the lack of predictability. Okay. If a process is random, we can't know exact outcome. Okay. But whereas in classical, it is fixed. The outcome is fixed. But whereas here, we can't know the exact outcome. We just say the probability. For example, I am tossing a coin. It may be head or tails. I just say the probability. For example, if I'm tossing the 1024 times, I just say this many times is there the possibility of it, this many times the possibility of it. That's it. That is what we get in randomness. So in quantum mechanics, some events are fundamentally random. The kind of randomness is built into mathematics theory. through Bond rule. Okay. It tells us the probability of an event, not the certainty. That's what you need to remember. What does Bond rule say? It just say the probability. We can't say the exact outcome. Okay. Now moving on to the second concept, determinism. So what is determinism? It is the belief that the future is fixed. What is that? The future is fixed. Okay. The For example, if I throw a ball, I can say where it can land. Means the future is already fixed. Okay. But whereas in quantum, we'll be having indeterminism. What is indeterminism? So in quantum mechanics, we can't predict exact outcome. We only predict the probability. That is nothing but the randomness. Okay. Now moving on to the last topic, observer role and observer effect. What is observer role? For example, I am having a quantum particle if someone is observing it, let us say, or if someone wants to measure it. Let us talk about observer here because it is in the topic, it is in the syllabus. So, if I observe a particle which is in interference pattern, you need to remember if I have any terminology like interference, the interference patterns will be like this. If observer tries to see this interference pattern, then it will change to some dot or some like this. It won't look like interference pattern. So that is what observer effect or observer effect will happen in quantum. In quantum mechanics, the act of measuring something, it leads to the change in quantum state. If it is in a superposition state, if I want to measure it, then it will become either to 0 or 1. That is what the measurement or observer effect do. This is known as observer effect. We can't observe a quantum system without disturbing it. If we want to observe it, then we are disturbing it. If we are disturbing it, it will collapse. That is what simple agenda. I think this is done. Okay, non-locality in systems and even the role of entanglement. It is if it is there, I will finish here itself. Quantum gates. Next, what is there? Poly X gate, poly Y gate, information. Next, quantum information fundamentals. Hermitian operator. What is there? So, one small correction. So, Hilbert space. So, these you need to write, sorry. A linear vector space or a complex numbers. For example, I am having a linear vector space. Okay, a 2D space. So I am having two states, ket psi 1 and ket normal psi 1 and psi 2. So in between, there will be these quantum state psi. So how I am writing C1 psi 1 plus C2 psi 2. So if I do the summation of I C1 psi 1. So whenever we define a quantum system, we need a Hilbert space. So the space simply say the element of Hilbert. For example, there are two vectors psi 1 and psi 2, and here is a quantum state. So how I am writing the linear combination in quantum is nothing but these things. Ket psi 1 is equal to c1 psi 1 plus c2 psi 2. Okay, H is a space spanned by psi 1 and psi 2. H space is spanned by psi 1 and psi 2. Okay, I think this is about a linear Hilbert space. I think this is enough. What is there next? I think the role of entanglement, non-locality is very simple. So non-locality is there. I will explain here itself. It is the idea that entangled particles show correlations that cannot be explained by physics. Okay, that you need to write. It cannot be explained. Any local, if I want to know the locality or non-locality, I can't explain. It can't be explained how it is happening. Okay. So locality means that an object is influenced by its immediate surroundings. For example, if I am teaching you the class right now, for example, someone comes and disturbs me, then there is the immediate change, right? I say you to go or some you to go from the room because I am teaching the class, because I am influenced by the surrounding. That is what locality. But whereas in non-locality, the objects are instantaneously influenced by distant event, because in quantum the particles are entangled even far apart. So if something happens to the particle which is far apart, okay, it will reflect instantaneously. So that is what here non-locality means, okay. And that influence propagates at a finite speed, okay, which is nothing but at below the speed of light. The speed of light is the fastest speed. It can instantly occur below the speed of light. Okay, exponential qubit is nothing but 2 power n. I think we have finished unit 4, unit 2. So is that clear? Let me know in the comment section. let let us start unit 3. I will just quick recap unit 3. If yes, let me know in the comment section. Some doubts are there. What is the doubt? Please post in the this thing. Yasir Hussain. Yasir, please post your doubt. What is your doubt? I am again and again saying the agenda of this class. Some are there in border. I don't want to lose that student also. I want everyone to achieve good marks in quantum. That is the main reason I am investing time on Sundays also. It is not like a time pass. I think uh, this shows your seriousness. So still 46 are there. Still you are not joining. I think why you people are taking this much easy, I don't know. Because uh, correction may be in my hand or some other way. Some other faculty may correct or some other person may correct. Some are not even able to write what is ket psi and what is ket zero also. Okay. So if that happens in semester, you may loss, because until now I have given some partial marking or some other way. So that's the reason you are getting the mid average above 15. But if you write the same things in the semester, you may lose. What is the then? I think the effort I put to pass in mid, it is waste, right? Think you people are not at all serious. Classical bit versus quantum bit means classical bit is nothing but 0 and 1 binary digits, because classical computer always process using bits that are nothing but 0 and 1. But whereas quantum bit is nothing but 0 comma 1 or both we call it as superposition. Okay, I think that is clear. Still any doubts? So please utilize the session, because I want you people. So no other faculty is giving you time. No other faculty is mainly uh, elaborating the topics again. You are studying by your own. I think uh, why what is the reason behind the class is nothing but uh, I thought the exam will be on Monday, but someone said it is on Tuesday. So that is the reason I can cover some basic important topics, because unit 1 and unit 2 you can score easily. Out of if a question, if unit 1 unit 2 combinedly come for 30 marks, you can score 30 by 30 if you listen it carefully. Because unit 1, unit 2, unit 3 is very simple, and unit 4 is completely application oriented. I think in my point of view, only unit 4, it is some mathematical calculation. Unit 3, unit 2, unit 1 and unit 5, it is very easy. Okay. About polarization. So polarization is nothing but so we are having uh, two ways to travel a photon. One is horizontal, another one is vertical. Horizontal and vertical. If the photon is traveling diagonally, we call it as superposition. If it is horizontal, we are representing it as ket0. If it is vertical, we are representing it as ket1. That is about polarization qubit. So polarization is carried as waves. Okay, it may be vertical. If it is vertical, we are representing the basis as ket1. If it is horizontal, we are representing it as ket0. I think that is for about polarization. Still any doubt? TFI 10109, TF 109. So in photon qubit, you please try to mention. Photon has three types: polarization, path, time. Okay. In every situation, in everywhere, you try to visualize, make the diagrams very neatly. Try to write very neatly. Okay. So that will boost you. Still any doubts? Let me know. Then we'll proceed to unit 3. If no doubts, please let me know in the comment section. Hilbert space, you can try to refer it from the class notes, because class notes is not clear. At the point of time, I am not having the a clear class notes. So that is the reason I couldn't explain it very clearly. So that is Hilbert space is nothing but it is a 2D space where it represents a quantum system. For example, here is the quantum system. It is spanned by two vectors. So I am writing the linear combination. For example, it is ket psi1 and it is ket psi2. So I'm writing the linear combination C1 ket psi1 plus C2 ket psi2. So C1, C2 may be, as in your point of view, you may write alpha and beta also. To represent the quantum system, we are writing, we are using Hilbert space. Okay. So the theory concept, please go through the class notes. So quantum coherence and decoherence is nothing but if there is no disturbance from the environment, we call it as coherence. And if we are having any disturbance from the environment, we call it as decoherence. What happens if there is any disturbance from the environment? So the quantum system is fragile. I think in unit 3 it is there. Quantum system is fragile. Fragile, it is nothing but sensitive. If the quantum system interacts with the environment, it will collapse. So that is why we require long coherence time to maintain or to have a qubit to stay for long working period. We need to have long coherence time. If there is no long coherence time, we can't compute. So all these things, quantum communication, quantum sensing, quantum computers, everything will not work if we are having any disturbance. Disturbance is nothing but macro magnetic fields, noise, etc., etc. That will be there in unit 3. I will explain. Still any doubts? If yes, please proceed. Yes, I will let me go through unit 3 and I will quick recap because it is completely theory point of view. I will just explain what you need to write, what you need to mention on the class notes. Role of entanglement. So, what is entanglement? Entanglement is nothing but if you are having one state, for example, if particle 1 is having zero state, let us say, particle 2 also will have zero state. Okay. If I'm sending one information to particle 1, particle 2 also receives the same information. Even they are far apart. I'm again and again saying this, you need to remember. Even they are far apart. They are not like they are not like beside. They are far apart. Even they are 1,000 kilometers, 10,000 kilometers, even they are somewhere. So I'm in India, someone is in America. They're getting the information, right? That is the role of entanglement. We can transfer the information securely. Okay. Still anything? Still any doubts? If yes, please proceed. Yes, I will go through unit 3 and I will finish in half an hour or 40 minutes. It is hardly takes 40 minutes. So Okay, thank you. So please ask your friends to join because unit 3 it is, please కొంచెం తెలుగులో చెప్పండి. We'll see in the next unit 3 will I will also speak in Telugu also, no issues. Okay. షేక్ హఫీజ్ తెలుగులో చెప్పాలా హఫీజ్ నీకు? ఇంగ్లీష్ అర్థం కావట్లేదా? Hmm? The main agenda of to start this YouTube class is nothing but it will have some recording again in my channel. So better if someone is missing, if someone is not understanding any certain point of time, you can ask me. You can say you can write some time. Sir, this time I am not understanding this topic, and again I will refer my YouTube video. Okay, then I will explain. If it is personal, also I will teach. But the thing is, I want 100% result. The agenda is very clear. I want 100% result from quantum. I don't want anyone to fail in my subject. Please నాకు సహకరించండి. That is what I convey from my side, because if the I'm giving my more than more than efforts for this particular subject, because it is my first subject, okay, in my career. So you are my first students, so I want 100% result. I already said in the class also. Okay, please support. I want the support from your side. So 200 students are there, still only 51 are there in the live session. Just think of what is the seriousness of you people. Hmm? చెప్పకపోయినా మేము పాస్ అయిపోతాం సార్ అంటారా? పోనీ అలా అయినా చెప్పండి, పర్లేదు. నేను ఇంత ఎఫర్ట్ పెట్టాను కదా. Shall we proceed to unit 3? I don't want to discuss more. నాకు decoherence అవసరం లేదు. I don't want to disturb. Shall we proceed unit 3? If yes, please post yes in the comment box. Ask your friends to join also. Better, because unit 3 and unit 4 is some complicated. There are some complicated topics. Okay. So we'll proceed. Okay, thank you for the confirmation. And once for 1 minute I will stop. Please ask your friends also to join, because unit 3 and unit 4 it is compulsory, necessary. You post in the group. CRs, please do that job. So meanwhile I will start the session. But the thing is, you need to post your friends to ask your friends to join, because it is very important. Unit 3 and unit 4, I think some big questions may come from these particular units only, like 5 marks or 10 marks questions, because there are some big topics are there in this particular unit 3 and unit 4. Okay. Okay, I'm starting unit 3. So in unit 3, the first topic is nothing but what is required to build a quantum computer. That is nothing but we need to give the conceptual overview. If any question comes, I'm again and again saying it, the question may be anything. So if any terminology look like required to build a quantum computer, or what are the things required to build a quantum computer, or some other way, the questions may be, it is not like direct, like what is there in the syllabus. It may be some different way. So the thing is, we need to remember the terminologies and you need to write. So what is required to build a quantum computer? The first thing is nothing but we require qubit. Okay, initially we require qubit. Qubit లేకుండా మనం క్వాంటం కంప్యూటర్ చేయలేము. Okay, first thing we require qubit. Okay, and then after qubit you need to write what are the types of qubits which are there in quantum. Already I mentioned here itself. I said you need to write spin qubit, path qubit, time qubit, polarization qubit, okay, photon qubit, everything. After writing what is qubit, then you need to write what are the types of qubit. Okay. I think I will go with the class notes better. So, as per the requirements that is said by a famous scientist, DiVincenzo, as per him, I have listed these requirements as per David DiVincenzo. I think it is there. Uh, Building QC. So I think it is there. Okay. I think from here. So it is there. It is very clear. Better I will go with these notes. So in 2001, a small correction I mentioned 2000 in the class notes. You try to do a small correction. In 2001, David P. DiVincenzo is the scientist who is the scientist of IBM, proposed 5 essential rules for building a functional quantum computer. Okay, what are those 5 essential things? Scalable system of well-defined qubits, that is nothing but qubits. Ability to initialize to to a non-qubit, that is nothing but we need to able to understand whether the qubit is in ket 0 or ket 1. So the third thing we require to process that qubits, we require long coherence time, and for operating them we require quantum gates, and at the last we require quantum qubit specific measurement capability, that is nothing but at last we need to measure, right? Okay, that is what at the last. And I'm explaining the first thing, scalable system of well defined qubits. So we must clearly define the qubits. Okay, so physically we can derive the qubits by atoms. You already know atom, ion, photonic qubits, superconducting circuits, everything, right? So we need to first, the thing is, we need to have the qubit. We need to make the qubit. Okay. So for example, superconducting qubits are already made by IBM, Google, and trapped ions qubits already made by IonQ, which is the famous company. Okay. And that after building the qubits, okay, we need to initialize them, whether the given qubit is in ket 0 or ket 1. Okay. The second thing is initialization. Before computation, all qubits must start with usually ket 0. So before you are going for building quantum computer, first you need to make the qubits, and then you need to make the qubits start from 0. Okay, a clean initial state that ensures accurate computation. Why we are need to make it to 0? To make accurate computation. Okay, random starting states would produce meaningless results. For example, if you are thinking qubits are having ket 0 and ket 1, right? So why we need to only start with ket 0? So the reason behind that is nothing but if you start randomly, then it will produce meaningless results. Okay, that is the reason you need to start with ket 0 initially. And in practice, superconducting qubits are initialized using cooling to the ground. Okay, and trapped ions use superconducting required cryogenic cleaning, mine that is nothing but 15 millikelvin. Okay, it requires high cooling. Okay, whereas trapped ions use lasers or microwave resets. Now qubits వచ్చాయి, qubits basis మనం జీరో నుంచి స్టార్ట్ చేసాము, బట్ అది కాదు మనకి ఇంపార్టెంట్. ద ఇంపార్టెన్స్ ఈస్ లాంగ్ కోహరెన్స్. మనం దాన్ని డిస్టర్బెన్స్ లేకుండా పెట్టాలి. ఆ క్యూబిట్ మనం తీసుకున్న క్యూబిట్ ని తయారు చేసిన క్యూబిట్ ని డిస్టర్బెన్స్ లేకుండా ఒక ఎన్విరాన్మెంట్ లో సెట్ చేయాలి. ఎలా? సో ఎంతసేపు మనం డిస్టర్బెన్స్ లేకుండా మన క్యూబిట్ ని మనం పెట్టగలిగితే ఒక రూమ్ లో, దట్ విల్ మేక్ ద ఆపరేషన్స్ మోర్. ఓకే, మనం ఎంతసేపు అయితే పెడతామో అన్ని ఆపరేషన్స్ ఎక్కువ అవుతాయి. ఒకవేళ మనం కోహరెన్స్ లేకుండా జస్ట్ క్యూబిట్ తయారు చేసి నా పని అయిపోయింది అనుకుంటే, we will lose the information. There is no point that it will uh, give some advantage to you. Okay, so that is why I given coherence is far better than operation. Operation కాదు important, మనకు కావాల్సిన టాస్క్ కాదు మనకి ఇంపార్టెంట్. The thing is we require coherence. Okay, and the fourth one is nothing but universal set of quantum gates. సో క్లాసికల్ కంప్యూటర్ లో మనకి మీకు తెలుసు ఆల్రెడీ అండ్ గేట్, ఆర్ గేట్, నాట్ గేట్, అవన్నీ ఉంటాయి. బట్ వెరాస్ ఇన్ క్వాంటమ్ కంప్యూటర్ లో విల్ బి యూజింగ్ హడమాట్ గేట్. Hadamard gate is nothing but it creates superposition. H of ket 0 is nothing but 1 by root 2 ket 0 plus ket 1. H of ket 1 is nothing but 1 by root 2 ket 0 minus వచ్చింది. H of ket 1 పెట్టినప్పుడు మైనస్ వచ్చింది, మైనస్ 1 by root 2 ket 1. T gate, phase gate or T gate changes the qubits phase. Nothing but plus ఉంటే మైనస్ చేంజ్ చేస్తుంది. మైనస్ ఉంటే ప్లస్ చేంజ్ చేస్తుంది. ఆల్రెడీ C naught మీకు తెలుసు. If it is control is 0, the target will be the target won't flip. If the control is 1, the target flips. Already మీకు తెలుసు. These are some universal set of gates. Okay. And fifth requirement as per డివిజన్సో నేను మళ్ళీ చెప్తున్నాను. ఇది నా ఎక్స్‌పెక్ట్ లో కాదు. యాస్ పర్ డివిజన్సో నేను చెప్తున్నాను. 5 రిక్వైర్మెంట్స్ ఆర్ దేర్. ఫిఫ్త్ రిక్వైర్మెంట్ వచ్చేసి మనకిప్పుడు గేట్స్ అప్లై చేసాము. కోహరెన్స్ లో పెట్టాము. క్యూబిట్ తయారు చేసాము. క్యూబిట్ స్టేట్ ఇనీషియల్‌గా 0 పెట్టుకున్నాము. అన్నీ అయిపోయింది. ఇప్పుడు మనకు కావాల్సింది మనకు అవుట్‌పుట్ ఏమొచ్చిందని చెప్పి. అవుట్‌పుట్ ఈస్ నథింగ్ బట్ 0, 1 లేదు. నేను ఒక కాయిన్ టాస్ చేశాను 1024 టైమ్స్. హెడ్ ఎన్ని సార్లు వచ్చింది. అవుట్‌పుట్ మెజర్ చేయాలి కదా! సో టు మెజర్ ఇట్ మెజర్‌మెంట్ కన్వర్ట్స్ ద స్టేట్ ఇంటూ క్లాసికల్ రిజల్ట్. దీని అర్థం ఏంటి మీకిక్కడ? వాట్ డస్ ఇట్ మీన్? థింక్. వాట్ డస్ ఇట్ మీన్? సో ఇనీషియల్లీ it will be at 0 and 1 at the same time. Okay. But if I measure it, హెడ్ ఆర్ టెయిల్స్ ఉంది. నాకు హెడ్ కావాలనుకున్నప్పుడు ఓన్లీ హెడ్ విల్ బి దేర్ రైట్? హెడ్ ఓన్లీ ఒక హెడ్డే ఉందంటే ఇట్ ఈస్ నథింగ్ బట్ క్లాసికల్. టెయిల్ ఉందంటే ఇట్ ఈస్ క్వాంటమ్. సో మెజర్‌మెంట్ ఏం చేస్తుందంటే 2 అవుట్‌పుట్స్‌ని ఒక అవుట్‌పుట్ లాగా కన్వర్ట్ చేసేస్తుంది. ఓకేనా? ఇట్ ఈస్ క్లియర్ రైట్? దిస్ ఈస్ అబౌట్ అండ్ రిక్వైర్మెంట్ 6 అవసరం లేదు మీకు. ఇట్ ఈస్ నాట్ రిక్వైర్డ్. ఓకే. I think this is about basic requirements of as per డివిజన్సో. ఇక్కడ అదే రాసాను నేను. అండ్ ఇక్కడ మళ్ళీ మీరేం రాయాలంటే వాట్ యూ నీడ్ టు రైట్ హియర్ ఇస్ నథింగ్ బట్ ఫిజికల్ ఇంప్లిమెంటేషన్స్ ఆఫ్ క్యూబిట్. ఇప్పుడు క్యూబిట్ చేయాలి. ఎలా చేయాలి? దేర్ ఆర్ సమ్ ఫిజికల్ ఇంప్లిమెంటేషన్స్ ఆఫ్ క్యూబిట్స్. యూ ఆల్రెడీ నో సూపర్ కండక్టింగ్ క్యూబిట్స్. ఐఎమ్ నాట్ ఎక్స్‌ప్లెయినింగ్ అగైన్. ఎందుకంటే మీకు ఆల్రెడీ చెప్పాను. యూ నీడ్ టు రైట్ ఆల్ దోస్ థింగ్స్. సూపర్ కండక్టింగ్ క్యూబిట్స్, ట్రాప్డ్ ఆటమ్స్ అండ్ అయాన్స్, ఫోటానిక్ క్యూబిట్స్, స్పిన్ క్యూబిట్స్, క్వాంటమ్ డాట్, ఎన్వి సెంటర్స్, టైమ్ బిన్ క్యూబిట్, ఇవన్నీ ఉన్నాయి కదా! యూ ట్రై టు రైట్ ఆల్ దోస్ థింగ్స్. ఓకే. ఇంకా 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 మీకు ఆల్రెడీ చెప్పాను. సపోర్టింగ్ ఇన్‌ఫ్రాస్ట్రక్చర్ వచ్చేసి మీరు ఈ క్వెషన్ ఒకవేళ వస్తే, ఇఫ్ ఎ క్వెషన్ కమ్స్ రిగార్డింగ్ వాట్ ఈస్ క్వాంటమ్ కంప్యూటర్, యూ నీడ్ టు రైట్ 5 రిక్వైర్మెంట్స్ ఆఫ్ డివిజన్సో అండ్ దెన్ యూ నీడ్ టు రైట్ basic small some information about photon qubit, trapped atoms and ions, etc., etc. And then you need to I want this heading to be there because మీకు ఇది తెలియాలి. సపోర్టింగ్ ఇన్ఫ్రాస్ట్రక్చర్ వచ్చేసి ఒకవేళ సూపర్ కండక్టింగ్ క్యూబిట్ నేను చేయాలనుకుంటున్నాను. దెన్ ఐ రిక్వైర్ cryogenic cleaning. Cryogenic cleaning is nothing but extreme low temperature. That is nothing but 15 millikelvin. Okay. And we require lasers and vacuum chambers. Vacuum chambers in the gavali. For trapped ions, we are manipulating or we are trapping the atom to move to high energy state by using lasers and microwave. That is why we require lasers and microwaves. And we need control electronics. ఎందుకు కంట్రోల్ ఎలక్ట్రానిక్స్ కావాలి అంటే ఫర్ హై ఫ్రీక్వెన్సీ మైక్రోవేవ్ జనరేటర్స్ టు మ్యానిపులేట్ క్యూబిట్స్ వి రిక్వైర్ హై ఎలక్ట్రానిక్స్. అండ్ ఇంకొకటి ఏంటంటే ఎర్రర్ కరెక్షన్ హార్డ్వేర్ మనకు కావాలి. ఫర్ ఎగ్జాంపుల్ మనము ఎప్పుడైతే క్యాలిక్యులేషన్ చేస్తూ ఉంటామో దెర్ విల్ బి సమ్ ఎర్రర్స్ అకరింగ్ ఇన్ ద సిస్టమ్. టు లైక్ ఆ ఎర్రర్స్ ని మనం ఓవర్కమ్ చేయడానికి వి రిక్వైర్ సమ్ ఎర్రర్ కరెక్షన్ హార్డ్వేర్. ఓకే. ఎర్రర్ కరెక్షన్ హార్డ్వేర్ ఇస్ నథింగ్ బట్ ఆన్సిల్లా. ANCILLA. Sorry, I'm not able to write here. ANCILLA. That errors are nothing but syndrome. ఓకే. మీరు కావాలంటే అవి నేను తర్వాత గ్రూప్‌లో మెసేజ్ చేస్తాను. అండ్ దెన్ కరెంట్ ఛాలెంజెస్ ఏమేమి ఉంటాయి మీకు ఆల్రెడీ తెలుసు. స్కేలబిలిటీ. సో మనకి హై స్కేలబిలిటీ కావాలి టు బిల్డ్ క్వాంటమ్ కంప్యూటర్. నాయిస్ ఎందుకంటే డీకోహరెన్స్ వచ్చిందంటే మన క్వాంటమ్ సిస్టమ్ కొలాప్స్ అయిపోద్ది. అండ్ కాస్ట్ కూడా మనం 273 డిగ్రీస్‌లో పెట్టాలంటే వి రిక్వైర్ హై కాస్ట్. సో ఆల్గోరిథమ్స్ ఉన్నాయి. ఇప్పుడు క్వాంటమ్‌లో చాలా ఆల్గోరిథమ్స్ ఉన్నాయి. జోస్ ఆల్గోరిథమ్, డిష్ ఆల్గోరిథమ్, గ్రోవర్స్ ఆల్గోరిథమ్, షోర్స్ ఆల్గోరిథమ్ అవన్నీ రన్ చేయాలంటే అంటిల్ నౌ దే హావ్ ప్రూవ్డ్ ఆన్ ద పేపర్. అవి జస్ట్ థియరిటికల్‌గా మాత్రమే ఉన్నాయి. కానీ స్టిల్ దే హావెంట్ డన్ ఫిజికల్లీ ఇన్ క్వాంటమ్ సిస్టమ్. సో మనము ఆ కరెంట్ ఛాలెంజెస్ వచ్చేసి వి నీడ్ టు రన్ దోస్ ఆల్గోరిథమ్స్. ఐ థింక్ I, recently I came to hear that Shor's algorithm can break the encryption keys. That is nothing but mana WhatsApp, mana phone pay, everything that is linked with RSA encryption. RSA encryption ని break చేసింది Shor's algorithm in 1996 itself. But theoretical గా break చేసింది. To if the implementation occurs, మన privacy మనకు privacy ఉండదు. Because everything we use the social media platform all are end to end encrypted. ఇవి ఒకవేళ సోర్స్ ఆల్గోరిథం కానీ ఫిజికల్‌గా ఇంప్లిమెంట్ చేశారా, దెన్ ద ఎన్క్రిప్షన్ ఈస్ గాన్. మనకి ఎలాంటి ప్రైవసీ ఉండదు. ఓకేనా? దట్ ఈస్ వై దట్ ఈస్ ద మెయిన్ ఛాలెంజ్. ఒకవేళ మనం ఆ సెక్యూరిటీ గాని బిల్డ్ చేయగలిగితే we can do, right? That is what the challenge you need to write. Okay. This is about what is required to build a quantum computer. I think this, until this we have done. And next I'm moving on to fragility of quantum systems. Again, decoherence, noise, control, everything is there. So I will explain this. So fragility. What is fragility? నేను ఫ్రాగిలిటీ అంటే చెప్పాను. ఫ్రాగిలిటీ is nothing but sensitive. సో ఫర్ ఎగ్జాంపుల్ ఒక గ్లాస్ తీసుకోండి. నువ్వు దాన్ని కిందకి పడేయి. పాడేస్తే ఏమవుద్ది? గ్లాస్ క్యాన్ బి ఈజీలీ బ్రోకెన్, రైట్? ఈవెన్ ద క్వాంటమ్ పార్టికల్స్ ఆర్ ఆల్సో లైక్ దట్. ఫర్ ఎగ్జాంపుల్ ఆహ్, ఏ మన దగ్గర చిన్నప్పుడు బబుల్ ఊదుతుంటిమి కదా! నార్మల్‌గా ఇఫ్ యూ ఆహ్, ఆహ్, బ్లో ద బబుల్, ఇట్ విల్ గో ఇన్ ద ఎయిర్. ఒకవేళ మనం ఆ బబుల్‌ని టచ్ చేస్తే ఏమవుద్ది? విల్ బ్లాస్ట్, రైట్? ఆ! ఇట్ విల్ బ్రేక్, రైట్? సేమ్ లైక్ సేమ్ సిట్యుయేషన్ ఇక్కడ కూడా మీరు తీసుకోండి. ఫ్రాగిలిటీ ఈస్ నథింగ్ బట్ ఆహ్, ఈజిలీ బ్రోకెన్ ఆర్ డిస్టర్బ్డ్. So simply I can say if a balloon is blown in the air or left in the air, if I use pennies, ఒకవేళ నేను ఒక సూది తీసుకొని కూర్చోను. ఓకే. వాట్ హ్యాపెన్స్? ఇట్ విల్ బ్రేక్, రైట్? సేమ్ వే క్వాంటమ్ కూడా అంతే అదే అన్నమాట. ఇట్ కెన్ బి ఈజిలీ బ్రోకెన్. So quantum systems are very sensitive. That is what I am mentioning. Very sensitive. In small disturbance can collapse the system. Okay. So quantum system works using quantum states which are very delicate. సో మీరు ఇదంతా రాయాలి కంపల్సరీ. ఓకేనా? దే కెన్ బి ఇన్ సూపర్‌పొజిషన్ ఆర్ ఎంటాంగిల్ బట్ ది స్టేట్స్ ఆర్ ఈజిలీ డిస్టర్బ్డ్. అందుకోసమే దట్ ఈస్ వై కోహెరెన్స్ ఇస్ ఇఫ్ కోహెరెన్స్ మేక్స్ ఏ క్రూషియల్ రోల్ ఇన్ క్వాంటమ్. ఓకేనా? What is decoherence? Decoherence already చెప్పాను. Disturbance from the environment. What is noise? It is nothing but random disturbance from environment. It is like try to uh, have a quiet conversation, but this is a loud music. ఒకవేళ మనం నార్మల్‌గా మాట్లాడుకుందాం అనుకుందాం. ఫర్ ఎగ్జాంపుల్ ఐ యామ్ టీచింగ్ ద క్లాస్. Suddenly sound comes from background. It is some disturbance for you people, right? That is what noise. And control errors. Control errors are nothing but మనం ట్రాప్ చేసేటప్పుడు వి ఆర్ సెండింగ్ అక్యురేట్ మైక్రోవేవ్స్ ఆర్ ఎలక్ట్రోమాగ్నెటిక్ ఫీల్డ్స్ ఆన్ టు ఇట్. ఒకవేళ మనం అది ఒకవేళ ఇఫ్ యూ డూ దట్ సేమ్ థింగ్, మన కంట్రోల్ ఒకవేళ కానీ చేంజ్ అయింది అనుకుంటే దెన్ మన క్వాంటమ్ సిస్టమ్ మొత్తం కొలాప్స్ అయిపోద్ది. దట్ ఈస్ వాట్ అబౌట్ కంట్రోల్ ఎర్రర్స్. ఓకే. ఐ థింక్ దిస్ ఈస్ అబౌట్ ఫ్రాగిలిటీ అండ్ నాయిస్ కంట్రోల్. ఓకే. నౌ let us move to the one more important topic, that is nothing but conditions for functional quantum system. Okay. So what are the conditions we required to build a functional quantum system, working quantum system simply? So there are some headings. Isolation is nothing but coherence. Error management, typical some errors will be there. So ancilla will be there to manage this error management. Scalability, stability, so these are there. I think these are some theoretical concepts. I will explain, go through it fastly. So ఐసోలేషన్. సో ఇమాజిన్ ఏ క్యూబిట్. ఒక క్యూబిట్ ఉంది ఫర్ ఎగ్జాంపుల్. మీరు అనుకోవచ్చు ఈ క్యూబిట్ నేను ఎలా అయినా వాడుకుంటా అని చెప్పి. ఇట్ ఈస్ నాట్ పాసిబుల్. వి నీడ్ టు ఐసోలేట్ ద క్యూబిట్. ఓకే. it only wants to stay in its own world without being disturbed by outside noise like temperature, vibrations and magnetic fields. If outside disturbance comes, what happens? The qubit loses its quantum properties. That is called decoherence. Decoherence valla the qubit may lose its information. So if we have an electron spin representing ket 0 and ket 1, ket 0 is nothing but upward, ket 1 is nothing but downward, and someone or listens in or measures it. ఒకవేళ వేరే వాళ్ళు ఎవరైనా దాన్ని మెజర్ చేశారనుకుందాం. జస్ట్ థింక్ ఆఫ్, ఓకే, ఇప్పుడు ఆ 0, 1 లో ఉన్న సూపర్ పొజిషన్ విల్ బి కొలాప్స్డ్. So we need to isolate the qubit from the environment. It is completely we need to isolate from the environment. Okay. Now error management. Even ఒకవేళ మనం ఐసోలేట్ చేసిన తర్వాత గూడా సమ్ ఎర్రర్స్ విల్ కమ్. బికాస్ క్వాంటమ్ స్టేట్స్ ఆర్ వెరీ డెలికేట్. ఓకే. సో, మెజర్‌మెంట్ మిస్టేక్స్ క్యాన్ ఫ్లిప్. ఫర్ ఎగ్జాంపుల్ సమ్ ఇఫ్ కొన్ని ఎర్రర్స్ ఎలా అంటే బిట్ ఫ్లిప్ ఎర్రర్, ఫేస్ ఫ్లిప్ ఎర్రర్ వస్తుంటాయన్నమాట. ఇఫ్ ఫర్ ఎగ్జాంపుల్ 1 ఉందనుకుందాం. బిట్ ఫ్లిప్ ఎర్రర్ అంటే 101. సో, మిడిల్‌లో ఒకటి చేంజ్ అయింది. సో, ఆ చేంజ్ అయిన దాన్ని ఐడెంటిఫై చేయడానికి ఆన్సిల్‌లా ఉంటది. ఆ చేంజ్ అయిన దాన్ని వి కాల్ ఇట్ యాస్ సిండ్రోమ్. సో, ఐ విల్ ఎక్స్‌ప్లెయిన్ దిస్ లేటర్. బట్ ద థింగ్ ఈస్ ఎర్రర్ మేనేజ్‌మెంట్. దిస్ ఈస్ అబౌట్ ఎర్రర్ మేనేజ్‌మెంట్ అండ్ స్కేలబిలిటీ ఉంది. A small demo quantum computer with 10 qubits is good for real world problems. బట్ మన రియల్ వరల్డ్ ప్రాబ్లమ్ కొన్ని సాల్వ్ చేయాలంటే ఇట్ రిక్వైర్స్ హండ్రెడ్స్ అండ్ థౌసండ్స్ ఆఫ్ క్యూబిట్స్. సో, అక్కడ మనకి ఇప్పుడు 10 క్యూబిట్ సిస్టమ్ చేయాలంటేనే ఇట్ ఈస్ టేకింగ్ లైక్ ఏ రూమ్ స్పేస్. థింక్ ఆఫ్ ఒక హండ్రెడ్స్ ఆర్ 1000 క్యూబిట్ సిస్టమ్ చేయాలంటే. ఇట్ విల్ బి వెరీ హ్యూజ్ రైట్? సో, అండ్ వి రిక్వైర్ స్టెబిలిటీ ఆల్సో. ఏ క్యూబిట్ మస్ట్ హోల్డ్ ఇట్స్ స్టేట్ ఫర్ లాంగ్ ఇనఫ్. ఒకవేళ మనకి క్వాంటమ్ ఇన్ఫర్మేషన్ ప్రాసెస్ అవ్వాలి కరెక్ట్ అనుకుంటే ఇట్ షుడ్ స్టే ఇన్ లాంగ్ కోహరెన్స్. ఎలాంటి డిస్టర్బెన్స్ ఉండొద్దు. ఒకవేళ మన కంప్యూటేషన్ స్ట్రాంగ్ ఉండాలి. మన కంప్యూటేషన్ ఫాస్ట్‌గా అవ్వాలంటే. సో, అది గూడా ఒక ఛాలెంజే. ఓకే. దీస్ ఆర్ ద కండిషన్స్ రిక్వైర్డ్ టు బిల్డ్ ఎ క్వాంటమ్ కంప్యూటర్. I think until this point we are done. So, why maintaining entanglement is difficult? Okay. Error correction already mentioned. Now, క్వాంటమ్ హార్డ్‌వేర్ ప్లాట్‌ఫార్మ్స్ నేను చెప్పను. ఎందుకంటే క్వాంటమ్ హార్డ్‌వేర్ ప్లాట్‌ఫార్మ్స్ ఈస్ నథింగ్ బట్ సూపర్ కండక్టింగ్ సర్క్యూట్స్, ట్రాప్డ్ ఆటమ్స్ అండ్ అయాన్స్, ఫోటానిక్ క్యూబిట్స్. ఓకే. ఇక్కడ వరకు నేను చెప్పాను. ఎందుకంటే ఎర్రర్ కరెక్షన్ ఆల్రెడీ సెడ్ వై ఎంటాంగిల్‌మెంట్ ఈస్ డిఫికల్ట్. ఎందుకంటే వై ఎంటాంగిల్‌మెంట్ ఈస్ డిఫికల్ట్ ఈస్ నథింగ్ బట్ ఒక ఇన్ఫర్మేషన్ కరెక్ట్ పాస్ అవ్వకపోతే so, it requires ultra secure communication, and it requires ultra precise controls for maintaining entanglement. So, as of now, we are not up to that mark. So, that is the reason entanglement is required. ఒకవేళ ఈ క్వెషన్ why entanglement is difficult అని వచ్చితే, you write the definition of entanglement, you write the Bell state of the entanglement, you try to write the equation of entanglement, and you try to mention some things. As of now, we are not up to the mark. Okay, I think in the class notes it is there. If it is there, I will explain here also, here only. Why entanglement is difficult. So please look. అదేమంటే ఇట్ ఈస్ ద లింక్ బిట్వీన్ 2 ఆర్ మోర్ క్యూబిట్స్. ఓకే. ఇట్ ఈస్ నాట్ లైక్ ఒక పర్సన్ ఇంకో పర్సన్ అని కాదు. ఇట్ ఈస్ లైక్ థౌసండ్స్ ఆఫ్ పర్సన్స్. ఓకే. థౌసండ్స్ ఆఫ్ పర్సన్స్ ఇండియాలో ఉంటే మిలియన్స్ ఆఫ్ పర్సన్స్ ఇంకొక దగ్గర ఉంటారు. ఇట్ ఈస్ ద లింక్ అప్ బిట్వీన్ దెమ్. వెన్ 2 క్యూబిట్స్ ఆర్ ఎంటాంగిల్డ్, మెజరింగ్ వన్ ఇమ్మీడియేట్‌లీ టెల్స్ యూ ద స్టేట్ ఆఫ్ అదర్స్ రైట్? సో, ఒకవేళ ఎన్విరాన్మెంట్ ఇంటర్ఫియరెన్స్ అయిందనుకుందాం. ఎనీ ఇంటరాక్షన్ విత్ సరౌండింగ్ అది మొత్తం ఇన్ఫర్మేషనే ఫాల్స్‌కి తీసుకెళ్తది. ఒకవేళ నా దగ్గర మైనస్ ఉంది. నేను అక్కడ పోయేటప్పటికి అది ప్లస్ అయిందనుకుందాం. ఫేస్ మిస్ మ్యాచ్. అదయిందంటే మన ఇన్ఫర్మేషన్ మొత్తం లాస్ అయిపోయింది. దట్ ఈస్ వై ఎంటాంగిల్‌మెంట్ ఈస్ డిఫికల్ట్. ఒకవేళ ఎవరైనా దాన్ని మెజర్ చేయాలనుకున్నారు మన ఇన్ఫర్మేషన్‌ని. ఓకే. అది ఏమవుద్దంటే నా ఇన్ఫర్మేషన్ నేను షేర్ చేసిన ఇన్ఫర్మేషన్ మొత్తం పోద్ది. దట్ ఈస్ వై ఎంటాంగిల్‌మెంట్ ఈస్ డిఫికల్ట్. అండ్ అనదర్ వన్ ఈస్ synchronization problem. Large entangled particles, so networks require all qubits to stay in same rhythm. ఒకవేళ ఒక క్యూబిట్ గాని సిస్టమ్‌లో చేంజ్ అయిందా, దెన్ మిగతా క్యూబిట్స్‌లో కూడా ఇన్ఫర్మేషన్ పోద్ది. దట్ ఈస్ వై ఎంటాంగిల్‌మెంట్ ఈస్ డిఫికల్ట్. ఓకేనా? సో, క్వాంటమ్ ఎర్రర్ కరెక్షన్ ఇక్కడ చెప్పాను. బిక్ బి బి నన్నడిగితే ఇది మీరు చదువుకుంటే బెటర్. క్వాంటమ్ ఎర్రర్స్ ఆర్ నథింగ్ బట్ బిట్ ఫ్లిప్ ఎర్రర్, ఫేస్ ఫ్లిప్ ఎర్రర్ ఆల్రెడీ ఒకవేళ కావాలనుకుంటే యూట్యూబ్‌లో నా వీడియో ఉంది క్వాంటమ్ ఎర్రర్ కరెక్షన్‌ది. యూ క్యాన్ రెఫర్ ఇట్. నో క్లోనింగ్ థియరమ్. నో క్లోనింగ్ థియరమ్ ఏం చేస్తుందంటే ఇట్ ఈస్ ఇంపాసిబుల్ టు మేక్. నేను ఒక పాయింట్ చెప్పాను మీకు పొద్దున. వాట్ ఐ మెన్షన్ థట్ క్వాంటమ్ పార్టికల్స్ ఆర్ క్వాంటమ్ ఇన్ఫర్మేషన్ కెనాట్ బి కాపీడ్ అని. వై? బికాస్ ఆఫ్ నో క్లోనింగ్ థియరమ్. ఇట్ ఈస్ ఇంపాసిబుల్ టు మేక్ అన్ ఎగ్జాక్ట్ కాపీ ఆఫ్ అన్ ఆర్బిటరీ. ఇప్పుడు ఒకవేళ నేను ఒక ఇన్ఫర్మేషన్ షేర్ చేస్తున్నాను. ఇఫ్ ఐఎమ్ షేరింగ్ సమ్ ఇన్ఫర్మేషన్ ఇన్ ఎ క్యూబిట్, ఐ వాంట్ టు మేక్ ఎ కాపీ ఆఫ్ ఇట్, బట్ ఐ కాంట్ డూ ఇట్. ఓకే. సో, దట్ ఈస్ వై లాంగ్ కోహరెన్స్ టైమ్ ఈస్ రిక్వైర్. చిన్న డెలికేట్ డిస్టర్బెన్స్ వచ్చినా కూడా మే కొలాప్స్. క్వాంటమ్ సిస్టమ్ మే కొలాప్స్. దట్ ఈస్ వై వి రిక్వైర్ హ్యూజ్ ప్రిసైజ్ సిగ్నల్స్, హ్యూజ్ ప్రిసైజ్ కోహరెన్స్ టైమ్ ఎక్సెట్రా టు మెయింటైన్ అవర్ క్వాంటమ్ calculation stable. ఓకేనా? I think this is about until which point we are here. Now vision versus reality. The role of quantum software. ఒక రోల్ ఆఫ్ విజన్ వర్సెస్ రియాలిటీ. విజన్ ఈస్ నథింగ్ బట్ quantum hardware platforms already చెప్పాను. You need to write quantum dots, NV centers in this particular thing. So now moving on to vision versus reality. For example, the idea of quantum computing is good. For example, think of vision ఏందంటే నేను ఫాస్ట్ క్యాలిక్యులేషన్ చేయొచ్చు అనుకున్నాం విజన్. కానీ ఫాస్ట్ క్యాలిక్యులేషన్స్ కి వి రిక్వైర్ మెనీ మిలియన్స్ ఆఫ్ స్టేబుల్ క్యూబిట్స్. ఓకేనా? అండ్ వి రిక్వైర్ హై లాంగ్ కోహరెన్స్ టైమ్. ఇట్ బెటర్ యూ గో త్రూ దిస్ థియరిటికల్ నోట్స్. ఇది కూడా నేను ఎక్స్ప్లెయిన్ చేయలేను. Because already it is 2.5 hours. So better you please refer this class notes. So millions of stable qubits కావాలి ఒక క్వాంటం కంప్యూటర్ లో మనం వర్క్ చేయాలనుకుంటే. సో ఆల్రెడీ లైక్ ఐబిఎం 127 క్యూబిట్ ఈగల్ ప్రాసెసర్ అండ్ గూగుల్ 53 క్యూబిట్స్ హైకామోర్ కొన్ని ప్రాసెసింగ్ చేస్తా ఉన్నాయి. కానీ జస్ట్ థింక్ ఆఫ్ 127 క్యూబిట్ ఈగల్ ప్రాసెసర్ ఆర్ 53 క్యూబిట్స్ హైకామోర్ చేయాలంటే హౌ మచ్ దే ఆర్ ఇన్వెస్టింగ్ అండ్ హౌ మచ్ దే ఆర్ సెక్యూరింగ్ ఇట్. జస్ట్ థింక్ ఆఫ్. ఓకేనా? And long coherence. Long coherence, it is impossible. In vision, we would మనం అనుకోవచ్చు we can easily maintain అని చెప్పి. But in reality, we can't do it. ఓకేనా? సో ఎర్రర్ ఫ్రీ కంప్యూటేషన్ మన విజన్ లో ఉండొచ్చు. బట్ మా క్వాంటమ్ లో అలాంటివి ఇప్పటివరకు చేయలేదు. ఇట్ ఈస్ వెరీ టఫ్. సో రూమ్ టెంపర్ ఆపరేషన్ ఫర్ ఎగ్జాంపుల్ లైక్ క్రయోజనిక్ కూలింగ్ కావాలి. సారీ. సో క్రయోజనిక్ కూలింగ్ కావాలంటే వి కాంట్ మెయింటైన్ ఏ రూమ్ అట్ -273 degrees Celsius, రైట్? సో బట్ మన విజన్ లో వచ్చేసి రూమ్ టెంపరేచర్ ఆపరేషన్ లో చేయాలని ఉంటుంది. బట్ ఇట్ ఈస్ ఇంపాసిబుల్ యాజ్ ఆఫ్ నౌ. సో యూనివర్సల్ అండ్ పవర్ఫుల్ ఆల్గరిథం కావాలనుకుంటాము. బట్ ఇట్ ఈస్ వెరీ ఇంపాసిబుల్. ఓకేనా? యాక్సెసిబుల్ క్వాంటమ్ క్లౌడ్ కావాలనుకుంటాం. బట్ ఇట్ ఈస్ ఇంపాసిబుల్ యాజ్ ఆఫ్ నౌ. ఓకే. సో ఇవన్నీ బెటర్ గో త్రూ దీస్. ఓకేనా? So the gap between vision and reality I clearly mentioned. You try to refer this answer in class notes only. Okay na? Decoherence, noise, error correction, manufacturing challenges, cost and infrastructures are the gaps between our vision and reality, because we can't fulfill this gap easily, because it will have much cost. Okay, in every point of view it will cost you. Okay, and now moving on to the role of quantum software. So already you know special hardwares like superconducting circuits, trap atoms and ions, photons, etc., to build a qubit. Okay, but ఆ చేసిన క్యూబిట్ ని మన సాఫ్ట్వేర్ లో ఎలా చేయాలి? ఓకేనా? సో ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఇఫ్ యు ఆర్ హావింగ్ ఎనీ ఐడియా, ఇఫ్ యూ వాంటెడ్ టు సిమ్యులేట్ సంథింగ్, మనకు కొన్ని క్లాసికల్‌లో కొన్ని సాఫ్ట్‌వేర్స్ ఉంటాయి. లైక్ ప్రోగ్రామింగ్ లాంగ్వేజ్ సాఫ్ట్‌వేర్ సి, పైథాన్ మనం దాంట్లో చేసి మనం రిజల్ట్స్ చూస్తాం. బట్ మన క్వాంటమ్‌లో కూడా అలా కావాలి కదా! మన సర్క్యూట్‌ని మనం సిమ్యులేట్ చేయాలి కదా! దట్ ఈస్ వై వి రిక్వైర్ సాఫ్ట్‌వేర్, రైట్? ఓకే. సో వై వి రిక్వైర్ క్వాంటమ్ సాఫ్ట్‌వేర్? దే యూజ్ క్వాంటమ్ గేట్స్ ఇన్‌స్టెడ్ ఆఫ్ ఓకే. Why we need quantum software? Quantum computers work in completely different way. క్వాంటమ్ సాఫ్ట్‌వేర్ ఎందుకు కావాలి? క్వాంటమ్ గేట్స్ యూజ్ చేస్తాయి. లాజికల్ గేట్స్ అయితే మన క్లాసికల్ కంప్యూటర్‌లో చేసేయొచ్చు. దే ప్రాసెస్ సూపర్‌పొజిషన్ అండ్ ఎంటాంగిల్‌మెంట్. వేరాస్ హియర్ 0 అండ్ 1. ఇక్కడ సూపర్‌పొజిషన్, ఎంటాంగిల్‌మెంట్ కొత్తగొస్తాయి. ఓకే. దే మస్ట్ డీల్ విత్ ప్రాబబిలిస్టిక్ అవుట్‌కమ్. అది అవుట్‌కమ్ ఎలా ఉంటదో తెలీదు. బట్ వేరాస్ ఇన్ క్లాసికల్ ద అవుట్‌కమ్ ఈస్ ఫిక్స్డ్. సో వి కెన్ డీల్ ఈజిలీ. దట్ ఈస్ వై వి రిక్వైర్ క్వాంటమ్ సాఫ్ట్‌వేర్. సో క్వాంటమ్ సాఫ్ట్‌వేర్ హెల్ప్స్ టు మేనేజ్ ఆల్ ద డిఫరెన్సెస్. లైక్ ఇప్పుడు ఫర్ ఎగ్జాంపుల్ నా దగ్గర ఒక క్వాంటమ్ గేట్ ఉంది. నేను ఆ క్వాంటమ్ గేట్‌ని సిమ్యులేట్ చేయాలనుకుంటున్నాను. సో క్వాంటమ్ సాఫ్ట్‌వేర్ ట్రాన్స్లేట్స్ ద క్వాంటమ్ ఆల్గోరిథం or quantum circuit to give the probabilities. Okay, sending precise control signals. Okay, that is why I require quantum software. And correcting errors and interrupting measurement. For example, some error comes, I need to identify that error, right? So that is why I require quantum software. Okay, and the flow chart, మీరు ఫ్లో చార్ట్ కంపల్సరీ గీయాల్సింది ఎగ్జామ్ లో. అండ్ ఒక ఆల్గరిథం ఉంది. ఫర్ ఎగ్జాంపుల్ ఆల్గరిథం ఇస్ నథింగ్ బట్ యూజర్. ఓకే, and we'll be having a quantum compiler same as C compiler, Python compiler, అంటే which is nothing but the idea of us, we are translating to quantum compiler, and then we are building quantum circuit from the translator, and we should have hardware controller. Okay, and we need to have quantum processor to process the qubits, and at the last we need to know whether the what is the outcome. So that is why here it comes measurement and output, and last is nothing but క్లాసికల్ పోస్ట్ ఇస్తుంది. దట్ ఈస్ నథింగ్ బట్ 0, 1 లో ఉండదు. ఐదర్ 0 ఉంటుంది అవుట్‌పుట్ ఆర్ 1 ఉంటుంది. దట్ ఈస్ వాట్ వి కాల్ ఇట్ యాస్ క్లాసికల్ పోస్ట్ ప్రాసెసింగ్. ఓకే. సో, పాపులర్ క్వాంటమ్ సాఫ్ట్‌వేర్ ఫ్రేమ్‌వర్క్స్ ఉన్నాయి కొన్ని. ఐబీఎం క్యూస్కిట్ ఉంటది ఇప్పుడు ప్రస్తుతానికి. సో, అది ఐ ఆల్రెడీ మెన్షన్డ్ ఇట్ ఈస్ అన్ ఓపెన్ సోర్స్ పైథాన్ లైబ్రరీ. It allowed to you us to write, simulate and execute quantum programs on IBM real quantum computers. Okay, and one more thing is nothing but Google Circuit. It is a framework designed for Google's hardware. అంటే గూగుల్ సర్క్యూ ఇస్ నథింగ్ బట్ ఏ సాఫ్ట్‌వేర్. ఓకే. ఫర్ గూగుల్ సాఫ్ట్‌వేర్ లైక్ సైకామోర్‌కి మాత్రమే యూజ్ చేశారు యాస్ ఆఫ్ నౌ. ఓకే. ఇట్ అలౌస్ బిల్డింగ్ అండ్ రన్నింగ్ క్వాంటమ్ సర్క్యూట్స్ with flexibility for researchers, especially for researchers point of view. Google has built this Google Sycamore. Okay. And now at the last we are having same Microsoft Q hash. Microsoft Q hash is nothing but same as C hash. మన క్లాసికల్ కంప్యూటర్లో సి హ్యాష్ ఎలా ఉందో ఇట్ ఈస్ కంప్లీట్లీ ఏ క్వాంటమ్ లాంగ్వేజ్. సేమ్ సి హ్యాష్ లాగా క్యూ హ్యాష్ అనమాట. ఇట్ ఈస్ యూస్ ఫర్ ఆల్గరిథమ్ డెవలప్మెంట్ అండ్ క్వాంటమ్ సిమ్యులేషన్. అండ్ ద లాస్ట్ థింగ్ ఈస్ నథింగ్ బట్ అమెజాన్ బ్రాకెట్. ఇట్ ఈస్ ఆల్సో ఏ క్వాంటమ్ సాఫ్ట్‌వేర్ ప్లాట్‌ఫార్మ్. ఓకే. ఇక్కడ ఏంటంటే ఈ అమెజాన్ బ్రాకెట్ ఏం చేస్తుందంటే ఆహ్, ఇక్కడ సర్వర్ ఇక్కడ నేను కర్నూల్‌లో నుంచి I can access anywhere in the country or anywhere in the globe. So this is what the agenda. That cloud platform can be accessed by anyone. If I create some account with some username or some password, I can access from anywhere. That is what the agenda of Amazon bracket. This is about the quantum softwares. Okay. Now I think Unit 3 is clear. Let me know in the comment section. Is still any doubts? I will send all the PDF, no issues. But the thing is, if anyone having any doubt, please let me know. Please let me know in the comment section if you're having any doubts regarding Unit 3. I think మీరు ఏం రాయాలో మీకు ఒక క్లారిటీ వచ్చింది ప్రతి క్వెషన్‌కి. బికాస్ ఐ హావ్ మెన్షన్డ్ టాపిక్ వైస్ క్లియర్‌లీ. నో రైట్? థాంక్ యూ. థాంక్ యూ. థాంక్ యూ. లెట్స్ గో. షాల్ వి స్టార్ట్ యూనిట్ 4? యూనిట్ 4 నేను కొన్ని టాపిక్స్ నేను నా యూట్యూబ్ వీడియోలో రెఫర్ చేసేసుకోండి. Shall we start Unit 4? Thank you for the confirmation. So, moving on to Unit 4, if you look here, again quantum versus classical information. నేను స్టార్టింగ్ లో 15 డిఫరెన్స్ ఏవైతే చెప్పానో need to write again that things. Okay. And now comes basics of quantum communication. Okay. Basics of quantum communication. So, please look. So, quantum communication in 1970s and 1980s, early theoretical ideas of quantum ఆ టైంలో జస్ట్ సమ్ థియరిటికల్ ఐడియాస్ ఉండేది క్వాంటమ్ పార్టికల్స్ పైన. దెన్ scientists began the how information could be encoded from quantum particles. Then research introduced some fundamental principles like Schrodinger introduced చేశారు superposition and entanglement. Okay. In quantum in 1990s, so experiments confirmed that photons could safely carry quantum information. Okay. First demonstration used polarization, that is nothing but photon qubits use చేశారు. And they have seen that it is communicated securely. And in 2000s, development of optical fiber. Optical fiber is nothing but it is to optical fiber is nothing but ఒక మెటీరియల్ అనుకోండి, లేకపోతే ఒక స్పేస్ అనుకోండి, టు ట్రావెల్ టు మేక్ ట్రావెల్ ద ఫోటాన్స్. ఓకే. అండ్ ప్రాక్టికల్ టెస్టింగ్ ఆఫ్ లాంగ్ డిస్టెన్స్ క్వాంటమ్ ఛానల్స్ దే హ్యావ్ డన్. ఓకే, లాబొరేటరీస్ ఇన్ 2000s. మళ్ళీ చెప్తున్నాను, క్వాంటమ్ కమ్యూనికేషన్ ఇస్ ద మోడర్న్ వే ఆఫ్ ట్రాన్స్ఫరింగ్ ఇన్ఫర్మేషన్ యూజింగ్ క్వాంటమ్ పార్టికల్స్. So quantum particles are nothing but photons, atoms, electrons, etc., etc., ions. Okay. So instead of using normal signals, we are using quantum particles to transfer the signals, or transfer the energy, or transfer the information. So unlike classical communication, which sends bits, okay, in quantum communication, we are sending qubits. Okay. And you need again the same equation you need to write, ket psi is equal to alpha ket 0 plus beta ket 1. ఓకే. సో మళ్ళీ ఇదే వచ్చింది. ఇది మళ్ళీ రాయాల్సిందే. నో కాంప్రమైజ్. మళ్ళీ మళ్ళీ రాసేయండి. సో ఇన్ క్వాంటం కమ్యూనికేషన్ యూజెస్ నేచర్ ఓన్ లాస్, దట్ ఈస్ నథింగ్ బట్ టు కీప్ ద సెక్యూర్ అండ్ ప్రైవేట్, టు కీప్ ద ఇన్ఫర్మేషన్ సెక్యూర్ అండ్ ప్రైవేట్. ఇట్ అలౌస్ మెసేజెస్ టు ట్రాన్స్ఫర్ సేఫ్లీ. ఓకే. అది ఎంత సెక్యూర్‌గా ఉంటుందంటే, ఇట్ ఈస్ టిల్ నౌ సైంటిస్ట్ సే దట్ ఇట్ ఈస్ 100% హ్యాక్ ప్రూఫ్. నో వన్ కెన్ హ్యాక్ ఇట్. Okay, the principal foundation of the future for the future for quantum communication mainly is the future for quantum internet, because quantum internet is nothing but మనం ఇప్పుడు చాలా వరకు చూస్తా ఉంటాం, బ్రౌజ్ చేసాం. ఇప్పుడు రీసెంట్‌గా ఐబొమ్మ ఇన్సిడెంట్ అయింది. ఇఫ్ యూ ఆర్ బ్రౌజింగ్ ద సమ్ లింక్, మీ ఇన్ఫర్మేషన్ అంతా పోతుంది అక్కడికి. బట్ వేరాస్ హియర్ in quantum internet, it will not happen. Okay. Wait a minute. So quantum communication uses some basic information, basic principles: superposition, entanglement, and no cloning theorem. Due to no cloning theorem, it is 100%, it cannot be copied. And some measurement disturbance can create may lose the information. This is about quantum communication. So there is a two person, Alice and Bob. They wanted to share the information using quantum channel. Okay. So for example, I want to share the information of ket 0. I think you already know rectilinear, diagonal. I think this is how we need to share the information actually. But as of now, I'll explain with just in simple terms, ket 0, ket. And if for example Bob also receives ket 0, okay, okay. For example, in between, if Bob received ket 1, just think of, because if Eve tries to copy the information, what happens is nothing but ఈ కెట్ 0 కాస్త కెట్ 1 అవుద్దనమాట. లేదు, ఒకవేళ ఎవ్వరు కూడా మన ఇన్ఫర్మేషన్ హ్యాక్ చేయకపోతే, ద బాబ్ రిసీవ్స్ ద సేమ్ ఇన్ఫర్మేషన్. దట్ ఈస్ నథింగ్ బట్ కెట్ 0 ఇన్ బోత్ కేసెస్. సో అది ఎలా? ఇప్పుడు ఒకవేళ ఫర్ ఎగ్జాంపుల్ వాళ్ళకి కెట్ 0 వచ్చింది అని ఎలా తెలుసుకోవాలి? దేర్ కమ్స్ అథెంటికేటెడ్ క్లాసికల్ ఛానెల్. సో అథెంటికేటెడ్ క్లాసికల్ ఛానెల్‌లో ఏం చేస్తారంటే, బాబ్ అండ్ అలీస్ విల్ టాక్. ఏం చేస్తారంటే, నాకు కెట్ 0 వచ్చింది. నేను కెట్ 0 పంపించాను. నువ్వు కూడా కెట్ 0 పంపించావా అని చెప్పి వాళ్ళు ఒక ట్రయల్ యేసుకుంటారు. దెన్ ఇఫ్ దే థింక్ ఓకే, ఐ హావ్ ఆల్సో రిసీవ్డ్ ద సేమ్ ఇన్ఫర్మేషన్. ఐ హావ్ నాట్ రిసీవ్డ్ కెట్ 1. ఐ హావ్ రిసీవ్డ్ కెట్ 0 అని ఒకవేళ కన్ఫర్మేషన్ బాబ్ నుంచి వస్తే, దెన్ దే విల్ కన్ఫర్మ్. ఒకవేళ రాలేదు అనుకుంటే, దెన్ దేర్ కమ్స్ ద హ్యాకర్ వచ్చిండు కాబట్టి మన ఇన్ఫర్మేషన్ మనకి వేరే స్టేట్‌కెళ్ళిపోయింది. ఓకేనా? So some applications are nothing but satellites, fiber networks. So we'll be using quantum repeaters and quantum memories. For example, ఇది ఒక ఛానల్, ఫర్ ఎగ్జాంపుల్ ఒక 500 కిలోమీటర్స్ వరకు ఈ ఛానల్ పోద్దనుకుందాం. Again we are using quantum repeaters to extend one more 500. Again we are using quantum repeaters or quantum memories to extend this range. So we are, as of now, scientists are working on quantum repeaters. Okay. So I think quantum communication is very key, because the future quantum internet will be established using quantum communication. And in quantum internet, you need to write a teleportation circuit. It is mandatory. Mid 2 లో చాలా మంది రాయలేదు. If any question comes regarding quantum internet, they need to mention about quantum teleportation circuit. If the question is for 5 marks, at least, or 10 marks, you need to write quantum teleportation. It is mandatory. I'm again and again saying. And then I think this is not much enough. This is about quantum communication. I think that until that is enough. Basics is enough. And quantum key distribution, you please refer the video. Already I mentioned, I've already posted in the group also. And again, role of entanglement in communication, the same thing. The same thing as above in unit 3, what I mentioned in unit 3, you need to write. And the idea of quantum internet, I already mentioned, you need to write quantum teleportation circuit. Should I want to explain again teleportation? Please let me know in the comment section. Sir, please explain about quantum teleportation circuit. Huh? Okay, let me show you the quantum teleportation circuit. Uh, so this is the circuit. You please look. So Alice has the information. I'm explaining. Please, ఇంకా సాల్వ్ కూడా కావాలి సాల్వ్ కూడా చేయాలనుకుంటే నా యూట్యూబ్ వీడియో ఉంది అది రెఫర్ చేసి సాల్వ్ చేయండి. సో దిస్ ఈస్ ద ఇన్ఫర్మేషన్ కెట్ సై. నా ఆ కెట్ సై దగ్గర ఇన్ఫర్మేషన్ ఏముందంటే ఆల్ఫా కెట్ జీరో ప్లస్ ఆల్ఫా కెట్ జీరో. ఐఎమ్ నాట్ ఏబుల్ టు రైట్ ఆల్ఫా కెట్ జీరో ప్లస్ బీటా కెట్ వన్ ఇన్ఫర్మేషన్ ఉంది ఎక్కడ కెట్ సై దగ్గర. సో ఆ కెట్ సై ఎవరి దగ్గర ఉంది? ఆలిస్ దగ్గర ఉంది. ఓకే, ఆలిస్ దగ్గర కెట్ సై ఉంది. ఓకే, అండ్ దిస్ ఆలిస్ వాంట్ టు షేర్ దిస్ ఇన్ఫర్మేషన్ టు బాబ్. ఓకే, సో డైరెక్ట్ షేర్ చేస్తే ఇఫ్ ఎనీవన్ చెక్స్ ఇట్, సో మళ్ళీ మీకు ఇన్ఫర్మేషన్ తెలిసిపోద్ది. సో దట్స్ వై దే ఆర్ అప్లయింగ్ దీస్ క్వాంటమ్ గేట్స్. సో వాట్ ఆర్ దోస్ క్వాంటమ్ గేట్స్? So these are some quantum gates we are using: C naught gate and H gate. Okay, so C naught gate is nothing but you already know. If control is 0, target becomes nothing. If control is 1, target flips. And Adamant gate kuda meeku telusu. H of gate 0 creates the superposition with positive sign. H of gate 1 it creates the superposition with negative sign. Okay. Now this is nothing but measurement. దీస్ సింబల్స్ ఆర్ నథింగ్ బట్ మెజర్మెంట్. ఓకే, మనకి ఇక్కడ ఏమొచ్చిందో రిజల్ట్ మెజర్ చేయాలని చెప్పేసి వీఆర్ హ్యావింగ్ ద మెజర్మెంట్. ఓకే, కింద కూడా మెజర్మెంట్ ఉంది. ఆఫ్టర్ దాట్ రిసీవింగ్ బాబ్ ఎలా మెజర్ చేస్తాడు ఆ రిజల్ట్ అంటే యూజింగ్ ఎక్స్జెడ్ ఇస్ నథింగ్ బట్ పాలీ ఎక్స్ గేట్ అండ్ పాలీ జెడ్ గేట్. బాబ్ వరకు వద్దు, మనం జస్ట్ ఇన్ఫర్మేషన్ పై వరకే చూసుకుందాం ఫస్ట్. సో క్యూబిట్ 1 వచ్చేసి ఇన్ఫర్మేషన్ ఉంది మన దగ్గర. ఓకేనా? అండ్ ఒకవేళ నేను నేను మొత్తం ఎంటైర్ సర్క్యూట్ ని రాయాలనుకుంటే కెట్ సై ఆఫ్ 1 2 3 అని రాస్తాను. ఓకే, కెట్ సై ఇస్ నథింగ్ బట్ ఇన్ఫర్మేషన్ ఆల్ఫా కెట్ 0 ప్లస్ బీటా కెట్ 1. ఇది ఏంటంటే అలీస్ అండ్ బాబ్ కంబైన్లీ. ఓకే, మనకి అలీస్ అండ్ బాబ్ తో పని లేదు. అలీస్ అండ్ బాబ్ వచ్చేసి ఇక్కడ మీకు ఏం ఇక్కడ నుంచి మీరు ఏం చేసుకోవాలంటే దిస్ ప్లస్ సింబల్ రిప్రజెంట్స్ ఎంటాంగిల్మెంట్. ఇట్స్ కెట్ సై ప్లస్ అంటే ఎంటాంగిల్మెంట్ 1/√2 కెట్ 0 0 ప్లస్ 1/√2 కెట్ 1 1. ఇక్కడ అదే రాశాను. ఇఫ్ యూ లుక్ హియర్ before going on to that, 1/√2 ket 0 0 plus 1/√2 ket 1 1 ఉంటుంది. Then what I am doing is nothing but I am doing the tensor product. టెన్సార్ ప్రొడక్ట్ చేస్తే ఇలా వచ్చింది అనమాట. కంబైన్డ్ స్టేట్ ఇలా వచ్చింది. ఫస్ట్ థింగ్ మీరు ఆ సర్క్యూట్ నుంచి ఏం రాసుకోవాలంటే ఇన్ఫర్మేషన్ ఆల్ఫా కెట్ 0 ప్లస్ బీటా కెట్ 1. నెక్స్ట్ వచ్చేసి ఎంటాంగిల్మెంట్, ఆల్రెడీ ఎంటాంగిల్ అయి ఉన్నారు ఆల్ఫా అలీస్ అండ్ బాబ్. సో ఎంటాంగిల్మెంట్ ఈక్వేషన్ ఇస్ నథింగ్ బట్ 1/√2 ket 0 0 plus 1/√2 ket 1 1. If you do the tensor product, you will be getting this result. I can't write, so that is why I am giving you the fast explanation. మీరు ఒకవేళ కావాలి అనుకుంటే యూట్యూబ్ వీడియో ఉంది ఆల్రెడీ. ఐ హావ్ గివెన్ ఎలాబరేటివ్లీ. ఐ హావ్ రిటన్ ఎగ్జాంపుల్ ఉంది, అది చూసుకోండి. సో ఇక్కడ మీరు చూసుకుంటే వీఆర్ హ్యావింగ్ 4 పాసిబిలిటీస్: 0 0 1 1 0 0 1 1. ఇక్కడ నుంచి మనకు కావాల్సింది ఏంటంటే సి నాట్ గేట్ ఎక్కడెక్కడ ఉంది చూడండి ఒక్కసారి. సి నాట్ గేట్ 1 దగ్గర ఉంది, 2 దగ్గర ఉంది. సారీ, సి నాట్ వచ్చేసి 1 దగ్గర ఉంది, దిస్ ఇస్ 2 అండ్ దిస్ బి రిప్రజెంట్స్ 3. ఓకే, 3 తో మనకు పని లేదు. 1 దగ్గర 2 దగ్గర చూడండి. సో 1 వచ్చేసి ఇక్కడ 1 2 చూడండి 0 0. ఇఫ్ యూ లుక్ హియర్ 1 2 ఇస్ నథింగ్ బట్ 0 0. మళ్ళీ 1 2 చూడండి ఇక్కడ 0 1 అండ్ ఇక్కడ మళ్ళీ 1 2 చూడండి 1 0 ఇక్కడ మళ్ళీ 1 2 చూడండి 1 1 మనకు 3తో సంబంధం లేదు. జస్ట్ లుక్ అట్ ఓన్లీ 1 2. సో ఇఫ్ యూ టేక్ 1 2 0 0 is one possibility, 0 1 is one possibility, 1 0 is one possibility, 1 1 1 is one possibility. నేను 0 0 చూస్తున్నాను ఇప్పుడు ఫస్ట్. 0 0 చేసినప్పుడు C0లో కంట్రోల్ వచ్చేసి ఫస్ట్ క్యూబిట్‌కి ఉంది. టార్గెట్ వచ్చేసి సెకండ్ క్యూబిట్‌కి ఉంది. ఓకే. అయితే నాకేమొస్తది టార్గెట్ వోంట్ చేంజ్. మళ్ళీ 0 0 నే వస్తుంది. కంబైన్డ్‌లీ ఐ కెన్ రైట్ ఈస్ 0 0. ఓకే. మళ్ళీ సెకండ్ చూడు. కంట్రోల్ 0 ఉంది. టార్గెట్ 1 ఉంది. సో, ఐ డోంట్ బోదర్ అబౌట్ టార్గెట్. సో, మళ్ళీ నేను 0 1 అని రాసుకుంటాను. ఎందుకంటే కంట్రోల్ ఈస్ అట్ 0. ఓకేనా? నెక్స్ట్ వచ్చేసి కంట్రోల్ 1కుంది. టార్గెట్ 0కుంది. సో వాట్ హ్యాపెన్స్ టార్గెట్ విల్ చేంజ్. సో ఇది కాస్త 1 1 అవుద్ది. ఎందుకంటే కంట్రోల్ 1కుంది కాబట్టి. ఇక్కడ కూడా మళ్ళీ చూడండి కంట్రోల్ 1కుంది. టార్గెట్ 1 ఉంది. సో టార్గెట్ ఏమవుతుంది టార్గెట్ కాస్త 0 అవుతుంది. ఐ థింక్ దిస్ ఈస్ ద ఫైనల్ ఈక్వేషన్. మీరు C0 అప్లై చేసిన తర్వాత దిస్ ఈస్ ద ఫైనల్ ఈక్వేషన్ యూ విల్ గెట్. ఓకే. దిస్ ఈస్ ద ఫైనల్ ఈక్వేషన్. నేను మళ్ళీ చెప్తున్నాను C0 అనేది ఫస్ట్ క్యూబిట్‌కి, సెకండ్ క్యూబిట్‌కి మాత్రమే. థర్డ్ క్యూబిట్‌కి ఉండదు. సో ఆఫ్టర్ అప్లయింగ్ C0 లాస్ట్‌లో వచ్చేసి హడమాడ్ గేట్. హడమాడ్ గేట్ దేనికుంది ఒక్కసారి చూడండి మళ్ళీ. ఆఫ్టర్ అప్లయింగ్ C0 హడమాడ్ గేట్ ఓన్లీ ఫస్ట్ క్యూబిట్‌కుంది. సో ఇక్కడ నుంచి మీరొచ్చిన దాంట్లో నుంచి మళ్ళీ ఫస్ట్ క్యూబిట్‌ని సైడ్‌కి తీసుకోండి. సో ఈ ఫస్ట్ క్యూబిట్‌కి మాత్రమే హడమాడ్ గేట్ అప్లై చేయాలి. రెస్ట్ ఈస్ సేమ్. సో ఫస్ట్ క్యూబిట్‌కి హడమాడ్ గేట్ అప్లై చేసినప్పుడు హెచ్ ఆఫ్ కెట్ 0కి ఏమవుద్ది? కెట్ 0 ప్లస్ కెట్ 1 బై రూట్ 2. హెచ్ ఆఫ్ కెట్ 1కి ఏమవుద్ది? కెట్ 0 మైనస్ కెట్ 1 బై రూట్ 2. సో ఇఫ్ యూ అప్లై హడమాడ్ గేట్ ఇన్ దిస్ ఇక్కడ మీరు సబ్స్టిట్యూట్ చేస్తే హెచ్ సబ్స్టిట్యూట్ 1/2 1/2 ఇఫ్ యూ సబ్స్టిట్యూట్ 1/2 into 1/2 you'll be end up getting 1/2. So this is the final equation you will be getting. Okay, if you expand that you will be getting this as the final equation. Okay na? Then if you take కెట్ ఇక్కడ నుంచి ఏం చేయండి కెట్ 0 0 కామన్ తీయండి. కెట్ 0 1 కామన్ తీయండి. కెట్ 1 0 కామన్ తీయండి. కెట్ 1 1 కామన్ తీయండి. Then you will be having alpha ket 0 plus beta ket 1. I think in this particular example it is not there. Alpha ket 0 plus beta ket 1 వస్తే no operation is required. Okay. If మీరు ఆల్ఫా 0 0 తీసినప్పుడు నో చేంజ్. ఆల్ఫా కెట్ 0 ప్లస్ బీటా కెట్ 1 లానే ఉంటుంది. ఇప్పుడు 0 1 కామన్ తీసినప్పుడు యుల్ బి హావింగ్ ఆల్ఫా కెట్ 1 ప్లస్ బీటా కెట్ 0 ఉంటుంది. సో దట్ ఈస్ నథింగ్ బట్ we need to apply x gate. What x gate do? X of ket 0 is nothing but ket 1. X of ket 1 is nothing but ket 0. సో ఒకవేళ 1 0 కామన్ తీసినప్పుడు you need to apply z gate. Z gate is nothing but it does nothing to ket 0. It does కెట్ 1కి మాత్రం ఫేస్ ఫ్లిప్ వచ్చుద్ది. ఓకేనా? అండ్ 1 1 ఈ 1 1 వచ్చినప్పుడు 1 1 కామన్ తీసినప్పుడు ఇట్ విల్ బి లైక్ ఎగ్జిట్. సో ఐఎమ్ నాట్ ఏబుల్ టు రైట్ క్లియర్లీ హియర్. దట్ ఈస్ వై ఐ హావ్ గివెన్ ద బేసిక్ అండర్‌స్టాండింగ్. ఇఫ్ యూ వాంట్ ఎ క్లియర్ ఎక్స్‌ప్లనేషన్ ప్లీజ్ రెఫర్ ద వీడియో. ఓకేనా? స్టిల్ ఎనీ డౌట్స్ అబౌట్ క్వాంటం టెలిపోర్టేషన్? Still any doubts? Please let me know. I think we have finished unit 4. No, no. I think introduction to quantum computing, please go through the theoretical notes, right? And decoherence మళ్ళీ వచ్చింది. Decoherence and error correction మళ్ళీ చెప్తున్నాను. ఎర్రర్ కరెక్షన్ బెటర్ రెఫర్ మై యూట్యూబ్ వీడియో. అండ్ రియల్ వరల్డ్ ఇంపార్టెన్స్ అండ్ ఫ్యూచర్ పొటెన్షియల్ అవి మీకు మళ్ళీ ఇట్ ఈస్ లైక్ యూనిట్ 5లో వచ్చినాయి. ఇక్కడ రాసేయచ్చు. నో ఇష్యూస్ ఫర్ మీ. అండ్ క్లాసికల్ వర్సెస్ క్వాంటమ్ గేట్స్ ఆల్రెడీ ఒక్కసారి నేను ఫాస్ట్‌గా చెప్పేస్తాను. క్లాసికల్ గేట్స్ వర్సెస్ క్వాంటమ్ గేట్స్. సో బేసిక్ క్లాసికల్ గేట్స్ వచ్చేసి విల్ బి హ్యావింగ్ నాట్ గేట్. ఓకేనా? యూ ఆల్రెడీ నో నాట్ గేట్ గివ్స్ what does not gate do? So if it is 0 the output will be 1. If it is 1 output will be 0. నాట్ గేట్ అర్థమైంది కదా? సో the next thing is AND gate. Okay, if the if output is 1 only when both inputs are 1, rest all the things are 0. So that is what about AND gate. Okay, now moving on to another gate, OR gate. So output is 1 if only one input is 1. So 0 0 unte output will be 0. Rest all cases 1. OR gate. So NAND gate చూడండి, output is 0 only when the inputs are 1. Okay, When the inputs are 1, output will be 0. So only in this particular case, 0. In the rest all cases, it will be 1. And NOR gate, if you look here, output is 1 only when both inputs are 0. So 0 0 ఉన్నప్పుడు మాత్రమే NOR gate 1 ఇస్తుంది output. Rest all the cases, it will be 0. Okay. Now XOR gate. If you look XOR gate, output is 1 only when inputs are different. Okay. So if you look here, 0 1 inputs are different, so 1 1 0 inputs are different, 1. So rest all the cases, it is 0. And XNOR gate, it is nothing but output is 1 when both inputs are same. So if both inputs are same, 0 0 undi 1 1 ఉన్నప్పుడు మాత్రమే output will be 1. I think this is clear, right? About basic logical gates. Now let me go through some quantum gates easily. So identity gate is nothing but 1 0 0 1. Okay, ket 0 already manaku telusu, column vectors 1 0 and 1 0 1. If you do the matrix multiplication, identity gate does nothing. And if you do identity gate with ket 0, you will be getting ket 0. And identity gate valla manaki ilanti results change అవ్వలేదు. Okay. If you try to apply identity gate on ket 1, మళ్ళీ ket 1 వచ్చుద్ది మీకు, because identity gate does nothing to the qubit. Now the second thing is poly X gate. So if you look the poly X gate mathematical representation, 0 1 1 0. So if you apply here, if you apply X of ket 0, then you will be getting ket 1. That is nothing but it is flipping. Poly X gate ఏం చేస్తుందంటే మీరు ket 0 చేస్తే ket 1 వస్తుంది, ket 1 చేస్తే ket 0 వస్తుంది. That is what the operation of poly X gate. Now moving on to poly Y gate. This is the mathematical representation of poly Y gate. 0 minus I 0. Okay. And 0 minus I, if you apply with ket 0, you will be getting the same thing. That is nothing but ఒకటి చేంజ్ అయింది. మనం వీటి అబ్జర్వ్ చేస్తే ఇక్కడ మనకి 1 వచ్చింది. బట్ ఇఫ్ యూ అప్లై ఆన్ 1, యు ఆర్ గెటింగ్ 0. బట్ మైనస్ వచ్చింది ఇక్కడ ఫ్లిప్పింగ్. బట్ if you apply y on ket 0, it introducing phase, that is nothing but minus. That is what the basic operation of y gate. Now poly z gate చూడండి. Poly z gate, if you look here, this is the mathematical representation of poly z gate. So z of ket 0 చేసినప్పుడు you will be getting ket 0 only, no change in output. But if you do it for ket 1, z of ket 1 చేసినప్పుడు చూడండి, ఇప్పుడు you are getting minus, that is nothing but phase. So only the thing you need to remember is nothing but poly z gate చేసినప్పుడు minus వచ్చుద్ది. Now Hadamard gate, this is what Hadamard gate mathematical representation. 1 by root 2 1 1 1 minus 1. So 1 by root 2 1 0 చేసినప్పుడు then you will be getting 1 by root 2 1 1. ఇక్కడ నుంచి దీన్ని బయటికి తీయండి, 1 0 plus 0 1 రాసుకోవచ్చా నేను 1 1 ని? సో అక్కడ నుంచి మనకి ఈక్వేషన్ వస్తుంది, 1 0 is nothing but ket 0, 0 1 is nothing but ket 1. ఇక్కడ నుంచి మీరు ఇలా రాసుకోవాలి, దీన్ని గుర్తుపెట్టుకోండి. ఓకే. నెక్స్ట్ మూవింగ్ ఆన్ టు హడమార్డ్ గేట్ విత్ ket 1. ఇక్కడ మీకు చూడండి, ఇక్కడ ప్లస్ వచ్చింది కదా, ఇక్కడ నెక్స్ట్ థింగ్ హియర్ ఇట్ విల్ బి మైనస్, రెస్ట్ విల్ బి సేమ్. దిస్ ఇస్ నథింగ్ బట్ ఇట్ ఈస్ సూపర్పోజిషన్. నౌ ఫేజ్ గేట్ మీకు అవసరం లేదు, ఇట్ ఈస్ నాట్ రిక్వైర్డ్. ఓకే. టీ గేట్ కూడా మీకు అవసరం లేదు, జస్ట్ మ్యాథమెటికల్ రిప్రజెంటేషన్ రాసంటే రాసేయండి, బట్ ఇట్ ఈస్ నాట్ రిక్వైర్డ్. ఫేజ్ గేట్ ఇస్ what does this phase gate do is nothing but 1 0 0 minus 1 will be there. సో ket 0 కి ket 0 లానే ఉంటుంది, బట్ ket 1 కి వచ్చేసి I ఇంట్రడ్యూస్ చేస్తుంది అనమాట. I is nothing but phase here. ఓకే. టీ గేట్ వచ్చేసి 1 0 0 e pi by 4. ఓకే. సో ఈ 0 తో చేసినప్పుడు మ్యాట్రిక్స్ మల్టిప్లికేషన్ చేసినప్పుడు you will be getting ket 0. ket 0 is nothing but 1 0. ఒకవేళ 1 తో చేసినప్పుడు you will be ended up getting e power I pi by 4. This is also called as small phase shift. Okay. And controlled NOT gate, that is nothing but C NOT gate. C NOT gate mathematical representation వచ్చేసి 1 0 0 0. ఒక్కటి మీరు గుర్తుపెట్టుకోవాల్సిందంటే 2 ఎలిమెంట్స్ డయాగోనల్ వచ్చేసి తర్వాత 2 ఎలిమెంట్స్ ఇట్లా వెళ్తాయి అనమాట, అంతే. మిగతాదంతా మ్యాట్రిక్స్ రిప్రజెంటేషన్ సేమ్. ఓకే. సో ఇప్పుడు మీరు C నాట్ ఆల్రెడీ చెప్పాను. ఇఫ్ యూ అప్లై C నాట్ ఆన్ ket 0 0, ket 0 0 అనుకుందాము, ద రిజల్ట్ విల్ బి ket 0 0 బికాస్ ద రిజల్ట్ విల్ బి సేమ్. If you apply ket 1 0 పైన చేస్తే the result will change. How it will be changing? Because control is 1, target flips, right? So ket 1 1 గా మారుద్ది. That is what you need to remember. Okay. Now control CZ అవసరం లేదు. It is not required. I think this is enough for you people. Okay. This is about quantum gates and classical gates. ఒకవేళ మీరు అవి రాయాలనుకుంటే జస్ట్ మ్యాథమెటికల్ రిప్రజెంటేషన్ రాసి వదిలేయండి. ఇట్ ఈస్ సాల్వ్డ్ ఎగ్జాంపుల్ అవసరం లేదు నాకు. ఐ థింక్ యూనిట్ 4 is clear, right? Quantum key distribution and quantum teleportation, better watch my videos. I have given elaboratively. Quantum parallelism is nothing but it uses some fundamentals like superposition, entanglement. Okay, a quantum superposition వల్ల మన quantum parallelism అనేది ఉంటుంది. That is what about quantum parallelism. Now, is there any doubts still? Is there any doubt? Can you explain, please? Explain. No, no, no issues, not required. యూనిట్ 5 చెప్పాలా? లేకపోతే జస్ట్ యూ విల్ సారీ ఇఫ్ క్వాంటమ్ కమ్యూనికేషన్ కేమ్ ఫర్ ద ఎగ్జామ్ టు 5 మార్క్స్ వాట్ షుడ్ యూ జస్ట్ రైట్ వాట్ ఈస్ క్వాంటమ్ కమ్యూనికేషన్ అండ్ just mention about quantum internet advantages. That's enough. If it is coming for 5 marks. If any question comes regarding quantum internet, you try to write what is quantum internet. Then you need to elaborate the circuit and you need to write the answers, the calculations of the circuit. Okay. Next, till anyone? Any doubts still? No. So, better I will skip Unit 5 because Unit 5 is completely theoretical. No explanation is required. Okay. Or should I go with the flow? Better, please let me know in the comment section. Unit 5 explanation కావాలా వద్దా? No, sir. Thank you. So Unit 5 is completely, it is like if you see on the screen, these are the complete advantages will be there in Unit 5. So real world applications and ఏంటి healthcare. So better I will show the class notes also. You follow these class notes that I have shared in the group. Again, I will reshare all these class notes. So for example, quantum computing అంటే ఏంటి? Okay. So what is the use in healthcare? Healthcare లో ఏమేమి యూజ్ ఉన్నాయి? Healthcare లో యూజ్ ప్రతి దానికి నేను ఫ్లో చార్ట్ ఇచ్చాను. So this flow chart should be there, should be appear in your exam. And examples ఇచ్చాను. IBM ఏం చేస్తుంది, రోజు చేంజ్ చేస్తుంది. As what they are doing to discover all those things and material science లో ఎలా యూజ్ అవుద్ది. So all those things you need to give the explanation. That's it. Every slide and every topic I have given the flow charts. Better you make it very neatly in exam. Okay, it will boost you to score some marks. Okay. So this is about transports and logistics. Quantum communication, building a secure world and TNT. So quantum communication uses superposition, entanglement, no cloning theorem, QKD. So quantum key distribution is very important. I'm again and again saying if any question comes, sorry, if someone asked right now, just now, if any question comes regarding quantum communication, you need to write quantum key distribution also. In quantum key distribution, BB84 protocol ఉంటుంది. So BB84 protocol, you please refer from YouTube channel. If a question comes regarding quantum communication for 10 marks, you need to write BB84 protocol including quantum key distribution. Okay. And this is about some example of applications, navigation navigation, medical imaging, quantum clocks, etc., etc., etc. Industrial case studies ఏమేమి ఉన్నాయి పవర్కి మన quantum లో that you need to mention. I think India's national quantum mission already చెప్పాను. And careers in quantum ఏమేమి careers ఉన్నాయి అవి కూడా చేయండి. And popular job roles in quantum. Again, this is completely theoretical. No explanation is required. I think this is what about Unit 5. సో ఇంకేమన్నా మిస్ అయ్యి ఉంటే నా క్లాస్ నోట్స్ పెట్టాను ఆల్రెడీ. మీకు ప్రింట్ తీసుకొని పెట్టాను కదా! దాంట్లో చూసుకోండి. స్టిల్ ఎనీ డౌట్స్? ఎవ్రీథింగ్ ఈస్ క్లియర్ రైట్? I want 100% results from third year A, B, C section, three section combinedly. I want no one to pass, no one to fail. Sorry, no one to pass. Kazu. I want everyone to pass and everyone to score good marks. Okay. Okay. Shall we wind up? So I'm closing the session. Is that fine for everyone? Okay. Thank you. Thank you for